this Krakatau room. So this room will begin for match one. And I will invite for team D0048. Are you here? Okay, please get your seat first. And then for team 36. Okay, please get your seat. So please, before we begin, I would like to remind the operator first to set the screen. This one is team 48 and this one team 36. Okay, and now let me begin to explain again to reminder both of you. Our match, this match one, will begin with you must like sweet to know who will be the first presenter atau presentator. You will be the team defender or attacker by sweet. Okay. After that, I will give you for team defender. For example, you will be the team defender, and you will have 3 minutes to present your idea. 3 minutes. We don't give you more than that. Okay. So if the time is up, I will cut you to present. Okay. And after that, I will give operator time to reset the timer from 3 minutes to 6 minutes to begin the debate session. In debate session, team attacker just have 30 seconds to deliver your arguments or your comments and etc. And team defender just have 1 minute to give your argument to defend your idea. Okay, it's pretty clear. Yes, of course. You can present together or just one person. It doesn't matter. Okay. Okay. Please, for timer, before we begin, I would like to invite you to switch. Okay, pemenangnya Gunting. You will be the first presenter or team defender? Mau defender duluan? Okay, sip. Yes, you will be a team attacker. So please, for operator, please prepare for 3 minute slide for team 48. Defender will present. Yes. Kita. Yeah. Okay. For team 48, we'll start the presentation their idea. Yes, of course. I will give you after this, okay? This is yours? Yes? Okay, set the timer first for 3 minutes. Ya, bisa berdiri, bisa duduk. Okay, set the timer for 3 minutes. Where's the timer? Oh, okay. Are you ready for team 48? Oh, not yet. Okay. I will give you an start. Okay, give applause before we begin. Okay. Okay. For team 48, you can start from now.
Okay, good afternoon, everyone. I'm going to talk about our research on developing biomarkers for early cervical cancer screening. Next, we know next we know that this disease is still a big health problem around the world, and nowadays we still have a screening method that works well, but they often need an invasive technique, and that's not very easy to everyone to access it there. And then that's why we have a long-term goals that to develop a blood based test to do a cervical cancer screening earlier. And one of the promising solution is using microRNA, because this tiny molecule RNA is evolved in a lot of gene regulation and also cancer mechanism as well. And next, in this study, we used a nanostring technique that can profile microRNA. And then we use 12 paraffin tissue consisting of normal and cancer. Next, from the nanostring results, we profile over 800 microRNA. And among those, we discovered 62 up and 21 down regulate microRNA. And from the heat map data, we can clearly show distinct microRNA expression between cancer and normal. And then from the volcano plot, we can determine the most prominent microRNA between those up and down, and then microRNA 1246 as an oncogenic, and then microRNA 4542 5P as a tumor suppressor microRNA. And then next, for further understanding about the what kind of mechanism of those microRNA, we continued our study by using a gene targeted analysis. And then the results suggest us that those microRNA involved in several pathway of cancer formations. And then that's why this pair biomarker signature can be a promising pair biomarker as a candidate for the cervical screening biomarkers. And our next study is we want to validate those biomarker with a larger cohort. Thank you.
Okay, now we're gonna go to the session or debate session. So I would like to remind you again. In debate session, just 30 second for you give your attack to team defender, and team defender just have 1 minute to give to defend your idea. Okay, are you ready for debate session? For operator, are you ready? Please set the timer for 6 minutes. Okay, so for debate session we can start now.
Yeah, our inclusion is Balinese ethnicity, and the exclusion is the patient is not get treatment that didn't get any treatment, and also yeah.
And the inclusion, we include those early stage cancer, like stage 1 and stage 2, but not including any stage 3 and 4.
Okay, for the exclusion, can you explain more?
Yeah, so we exclude those patients that has um, criteria that they have like treatment. So that's it.
And also for those patients which didn't have any good paraffin tissue block.
Okay, what is I don't think it answer my question. What is the background on your inclusion and exclusion criteria? You say that Balinese, and why you choose Balinese? And because it's for a cervical biomarker for the general screening test, is it a represent of the biodiversity on Indonesian itself, and also the exclusion? Can you tell more about the background why you exclude the late stage of the patient? Thank you.
Okay, so we use this Balinese as a pilot study. So this is just pilot study first, and we will look like we want to look how the biomarkers, and we don't include later stage because we want to know the biomarker for early stage stage of cancer.
So as you said before that is it possible to generalize the result for the other
Indonesian population like that? Like this biomarker can use to the other Indonesian population like in Papua, in Java, and anything else like that.
Yeah, we think yes. But first we need to validate first about our peer biomarker signature that we found in this study, and we need to validate in the larger cohort, and then I think it's can generalize for those cases.
Okay, so can generalize, yeah.
Yeah. But we need to validate first for sure because this is a pilot study.
Okay. Okay, thank you. And as I know that cervical cancer has like many kind of types. Can you like tell us what the type of cancer that you use, cervical cancer type of use, and why you choose the that type like that?
So this is a squamous cervical cancer. It's not adeno cervical cancer. So it's like this squamous because it's 80% of the patient is usually this type of cancer. And this is early stage. So it's like early 1A, 1B, and also 2A and 2B, but not stage 3 or 4. So 1A, it means like, yeah, that's it.
Uh, uh, I forget if you mentioned about P60 negative before on your presentation, but can you describe more about why you choose the P60 negative patient for that, and why not also P60 negative and positive?
Yeah, for the ideal research, maybe we can compare it. But why we choose P16 negative? Because we don't want HPV affect the expression of microRNA. That's why we don't use HPV, because we know that cervical cancer can be affected by infection of HPV. So yeah, we exclude it, and then we don't want that HPV involved in the microRNA mechanism.
Dian, I'm sorry, but Dian, if, your, your goal is want to make a general screening cervical cancer, right? So, are these only for the P60 negative patient cervical cancer type, or it can be used both? Because your study only include P60 negative.
Oh, no, we will I mean we will do validate like with larger cohorts for sure. Yeah. So it's not gonna be just that samples in the future.
Okay, for your cohort study, it will be include both, but for the pilot study, only P16 negative.
Right.
But it can represent and make a suggestion that your cohort will be success or not, because the pilot study and the cohort is different inclusion criteria.
Yeah, actually, we just want to avoid the bias if we include both of 16 and not 16 HPV for this research. But yeah, we think that we can generalize between, but we see the validate the results of the study.
Okay, maybe for the last confirmation that Indonesia has like a blood-based test for the cervical cancer, blood-based test cervical cancer, or your research is the first novelty for the blood-based test. In Indonesia, is already blood-based test for the cervical cancer.
No,
No.
no, this not it's not yet. So it's not blast with test yet. So it's still like using the PA analysis.
Or for your research is the novelty for the blood-based test.
So it's in the future. Time is up.
Okay, give applause. Thank you. Okay, please the microphone first. Okay, because the time is up and then your score is equal, so we have adding time for 4 minutes. Okay, 2 minutes you will be the team defender, and then you will be team attacker, like that. But because you not start yet yours, so you will begin. Oh no, I'm forgotten. Sorry. Yeah. Belum. We go to the batch 2. Sorry, session 2. You will be the team defender and present your idea. Sorry, I'm forget about that. Okay, so please prepare for that. Okay, for this score, just 11 for team 48 and 11-2 for team 36. Okay. Please prepare for operator. The 3-minute slide for team 36. Is yours?
Oh, yes, right.
Okay, set the timer for 3 minutes. Okay, team 36, are you ready?
Ready.
Okay, you can start now.
Okay, good afternoon, everyone. My name is Putumas Ari Prenaputri. You can call me Ari and my friend Suwar. Today we will present our research titled Cost Effectiveness of Multi-Target Stool DNA-Based Screening for High-Risk Colorectal Cancer Population in Indonesia, a Markov Model Analysis. So, next. So, is screening really matters for CRC mortality rate? Yes, absolutely, because screening declined about 50% mortality of CRC patient. But in contrast, the compliance rate decreased over decade. Why? Because the modality of the screening for CRC right now, FIT, fecal immunochemical test, is lower sensitivity, which increase the colonoscopy demand, which make everyone don't like to do colonoscopy, don't want to do the colonoscopy. So, is there any alternative? Yes, there is a stool DNA test that which similar with FIT. It's non-invasive, but it's more expensive than FIT itself. So, it's more beneficial for Indonesia as a lower income country. So we want to address this issue by compare the cost effectiveness of FIT and Colotech and no screening among the high risk CRC population in Indonesia. We use Markov model simulation to analyze disease progression for 100,000 population with the intervention with Colotech, and the comparative is FIT annually and without screening. The observation will be compared the ISR value. The uncertainty analysis will be analyzed by one-way sensitivity analysis and probabilistic sensitivity analysis. And also we conduct a some scenario to see the different screening intervals and coverage level for our test.
Okay, next, we move to the result that we can conduct the base case analysis that we can find the ISO value is 91.2 that deem cost effective because the value is under the willingness to pay threshold in Indonesia. And for the scenario analysis, that for the best scenario is the scenario 5 is conduct the lowest ISO value. Next. This is for the sensitivity analysis that we conduct for the robustness of our model. For the deterministic sensitivity analysis that we can see in the comparator for the fit and for the node screening, this same the parameter that make the ISTAR value is widely ranged. The parameters such as the colotex pricing and discounting rate of utility and cost. Next. This is for the probabilistic sensitivity analysis that we can show that we can see that in the willingness to pay threshold, the probability being cost effective is 100% and 99% in the comparator with no screening. Okay, that's all about our presentation. Thank you.
Okay, time is up. Thank you for team 36. And now please set the timer for 6 minutes for debate session. Okay, operator, are you ready? Okay, for debate session, you can start now.
So will you include like patients for your study, like what they think about this?
No, your question is the patient include like for this study? No, because we use only the model simulation first. So we only use for the cohort simulation for this cohorts model simulation for our study, and we include for the inclusion that we based on the Permenkes in 2018 for the colorectal cancer.
I wanna add for the test itself, it's not invasive. As I mentioned before, the the compliance rate is really decreased because the invasiveness of the colonoscopy, and FITC give the lower sensitivity, which mean that the false positive will be increased. So we use the stool based DNA. It seems like FIT is not invasive. It's really easy to do at home, and all but give the higher sensitivity.
So like money is a big problem from Indonesia. It's like most of the patient maybe cannot afford that. Even the cost is higher for sure for the colorectal compared to FIT. So what do you think about it? Will that be possible to do it here?
That's why we do this study to see, firstly, the effectiveness of the Colotech if we apply it into the Indonesian population based on the income itself.
And also, we hope for our study that the government, especially for the Jaminan Kesehatan Nasional or BPJS, can include this screening method for the our like our healthcare BPJS for the make sure all the population in Indonesia can use this can assess this screening model, like a screening method like that.
So do you think it's gonna need so this technique can replace the colonoscopy?
For the coloscopy itself, it's not because it's the gold standard to detect the CRC itself. But the issue that we want to address is the less sensitivity of FIT. That before we jump to the colonoscopy, we need to do FIT with the less sensitivity and with make patient maybe when do the colonoscopy they will get the false negative.
I will continue because we cannot replace the colonoscopy because for the modality of the screening, this is the first use for the screening, and colonoscopy is like the follow up screening after the positive for ORFID or the colotech, and then we continue for the colonoscopy. So this is not cannot replace the colonoscopy.
But we can reduce the frequency to do the colonoscopy itself because the invasive that I mentioned before and the highest price of the colonoscopy.
In terms of screening period, what is the reason why you choose 5, 3, and 4?
Okay, for the why, the reason why we choose a 1 year, 3 years, and 5 years. For the 1 year, we will compare the with the fit. The actually the fit or FIT is used for the annually. It mentioned in the Permenkes in 2018. And why we choose the 3 year because one the product. Sorry, for the Colotech specification is mentioned that use Colotech in every 3 years, and for the 5 years we relate to the colonoscopy like that.
It mentioned on Permenkes also.
So how sensitive is this compared to the FIT?
The sensitiveness of the Colotech is up to 92% that we use in the study. For the FIT, it's like up to 80%, and but other studies shows the less sensitivity number. So we conclude to use the highest, but it's still lower than the Colotech.
What about the specificity?
Also the specificity in our studies show the specificity is about a 90%, yeah, up to 90%. Then the fit is a lower sensitivity.
Which country has been done this before?
For the specificity and sensitivity for the FIT and the Colotech, we use the another country because Indonesia it's not specifically do there's no study that we found use Colotech for to conduct sensitivity and specificity study. And for the FIT itself, we choose the highest sensitivity and specificity number, but it's for another country. So yeah, I think it's
Okay, for the statistical analysis, why you choose Markov model than the others?
Okay, why we choose the Markov model? Because in our study, we use the disease that like we know as the chronic disease. So the patient can be stayed in and stay in the same state like the patient can stay in the healthy state or stay in the cancer state like that. That's the reason why we choose the Markov model because the model is can show or represent the true or the real life what is the progression, the patient progression from the healthy and for the cancer until death like that.
How do you convince the policymaker to do this? I mean, regarding the cost is super expensive.
with the ISO value that we provide. So this is the initial study that we conduct, and then after this, if there's any change, we can widen our research and use the real life population in Indonesia, and use the different demographic of Indonesia, so we can publish our study, and the policymaker can consider to use our study to make this test become the mandatory.
We are a Balinese team.
Okay. Again, give applause for team 48. The winner from match one. Okay, maybe before we go to the next session, we have feedback from judges first. Maybe 1 minute or 2 minutes. Oh, okay.
Congratulations, both of the teams. You both are amazing. Maybe because the time limits. So I think it's difficult to state what your thought was because it's and it's a new. I think like not everyone understand the concept of mRNA or Markov model. Maybe it's very difficult also to tell us. So maybe uh, choose a easy word, simple word to tell us. Because like for me, like I have a difficulties or understanding what is the Markov model because I know it's very complicated, but please tell us in a play manner so we could understand. Maybe that's. But the teams, both of the teams are amazing. Yeah. Yeah.
Yeah, I actually the one also who is so deg-degan here as well when they're looking at the scores. Yeah, it's really tight. I think it's about time as well. Yeah. So I have the same note as Bu Monica before ya. When the siapa ini? The left team talk about like why you choose Markov model. I think it's worth to highlight that it's not about explaining the Markov model, but also you among those kind of models or those kind of methods, why you choose that, because the way you explain it, because some patients stay in the same state. It's not only Markov model, there's a lot of other method. So it's not um why you choose the answer should be why you choose specifically Markov model instead of A, B, C, D. So I think the answer should be that. I think the rest stays similar between both team. Yeah.
Okay, thank you for judges and thank you for team 36 and team 48. You can go back to your seat. Congratulations. You go to the next match. Okay, for the second match, please prepare for team 41 and team 35. Please get your seat. Are you here, team? Baru lagi, ini tim kedua. Where is team 41? Okay, get your seat, please. And team 35. Okay, please get your seat. Okay, are you understand the rule or I will remind you first? Okay, remind first. So before we begin, I will start with give you time to like sweet and to know if you winner on the sweet, you will be the team depender. And for team depender, you will be the first presenter or you will present your idea first. And for team not winner on the switch. So you will be the team attacker. And team attacker just have 30 seconds in debate session to attack your team defender. Okay? So I will give for you, both of you, to switch first to know who will be the first. Ya, yang menang ya duluan. Okay. You will be team defender or attacker? It's okay. So for team 48, please for operator set the PPT. Sorry, 41. Okay, 41. Set the PPT first. Yeah, this one. 41. 41. Okay, this is yours. Okay, and set the timer for 3 minutes. Okay, get the microphone first and the pointer. Yes, you can using it. Okay, for team 41, are you ready? Not really. Okay. Ready or not, you must do it. Okay. 1441, you can start your present now.
Okay, good afternoon, everyone. We are from the group D41, and this is our study. Okay, so next. Okay, so imagine a pandemic that doesn't make headlines, doesn't trigger lockdowns, but it continues to spread, yeah, borderless across the country, and then the species and also the ecosystem. It is an antimicrobial resistant. So this is a true silent pandemic. In its content, the E. coli is represent a significant role because as we know that this is a commensal in human gut, but actually it's also a major cause of serious infection with the high mortality and morbidity. And one of the most important mechanism is due to the beta lactamase enzyme production. So this enzyme could uh, inhibit the beta lactam antibiotics and the most common use of antibiotics. And in these terms, the WHO designed the ESBL producing E. coli as the global EMR indicators across human, animals, and environment, the One Health perspective. And it raised a critical question. What is the global landscape of beta lactamase genes diversity in E. coli? And to answer this question, we conduct a study to describe the diversity and global distribution of beta lactamase genes in E. coli across temporal and One Health dimension using the NCBI database. Next. Okay, so we retrieved the data from the NCBI on November 25th with the query E. coli isolates, and we have the specific inclusion and exclusion criteria. And after the filtered data will be categorized based on the One Health framework. Okay, next. So from the result, the temporal setting mentioned that the blood TEM1 consistently represent the largest share of acquired blood gene events. However, there are two important genes appears. The first one is the BLA CTXM15 that progressively become a larger proportion in the mid 2000, and then the BLA NDM5 after 2010. And it's actually correlate with the clinical literatures. Okay. Next, we also found that the most of the isolates is come from the clinical isolates from the human, but in general, we can see that Blatam and the BLASITXM together accounted about almost 70% of all. Thank you.
Okay, set the timer for 6 minutes for operator. Okay. Okay, you can start now.
Okay, the first question is what in that in that slide it it show that global diversity. What the definition of global that you guys are saying?
Okay, okay, thank you very much. But from the NCBI data set itself, they have metadata like geographic location, like country, and then almost all of the country have submitted to NCBI database, and then we collected from the information some like geographic location like from country and then other country, that we can conclude that this global diversity from our study.
Uh, okay, and if the dataset is not geographically balanced, it is valid to claim that it is a global diversity or
So actually, what we include in our study is we also filter from the location that we got. If there is no specific location or the geographical data, so we will exclude the data.
So I want to ask, do you use the statistical method? And if yes, what statistical method that you
Okay, thank you.
use?
We didn't not use statistical method because the data is set like submission bias. Yeah, we just use descriptive analysis.
Because we cannot control some of the important things to become the statistically analysis. That's why we only make the descriptive analysis.
Okay, so next question. Can the global beta lactamase diversity in E. coli be considered an emergent property of microbial ecosystem, shaped more by ecological networks and horizontal gene exchange than by organism level evolution?
Thank you. It's maybe show that like blood team blood CTS is acquired blood gene have some mobile genetic element. They can be shared some like other bacteria or some species of bacteria. They can cause like a uh, ecosystem and E. coli is from the commensal body then they have a contamination E. coli in the river and then they can contamination from the ecosystem itself.
So, in general, this genes is not only into the in E. coli, but E. coli is also part of the Enterobacteriaceae, and they share the genes as well.
And what is mean by the One Health approach in this study? Can you explain more about that?
Thank you. We use some categories like a three-level categories: human, environmental, and animal. Like from the World WHO organization, they have announced that ASAP have to know to study with One Health like human, animal, and ecosystem. Environmental.
Okay, so this terminology is not based on our, but the terminology is from the WHO. So the perspective is not only we see the problems based on the human side, but because it could be transferred to the other species as well. That's why there is a one health perspective that it conclude including the human and the animal and also the environment.
Okay, maybe next question is, in your slide, given that your analysis rely on observational genomic data from NCBI, how would you distinguish between the evolutionary selection for specific beta lactamase genes and apparent enrichment driven by sampling bias, clinical expansion, or outbreak sequencing?
Okay. Thank you. Because the NCBI is one of the depository data like you submit the data from the NCBI. Uh, this is not like to how to show the evolutionary genetic from the beta lactamase, but to show the how the like how the emergent new genes beta lactam form. Like yeah, if someone study have showed discovery the new gen beta lactamase, maybe they come submit to NCBI, then NCBI provide the data and we can choose the data.
Okay, so once more that this is actually not a surveillance data. It's only a snapshot that we take from the publicity database. So we cannot conclude or compare the correlation of something. So this is not something that we see as a part of the evolution, but we only see what is the distribution at that time.
Time's up. Okay, give us for team 41 and team 35. So now we can for sorry 6 for team 35 and 9 for team 41. Okay, now you will be the team center and please ready? Ready? Okay. So for team 35, you can start your now.
Okay, so our team research is determination of genetic markers associated with weedy rice using a generalized linear mixed model in a genome-wide association study. Next. Okay, so rice is a major staple crop consumed by more than 3.5 billion people in the worldwide. So it is highly important for global food security. Through the domestication, rice has developed important traits such as seed coat color, which distinguish cultivated white rice and weedy red rice. This trait is influenced by genetic variation, so this can be studied with the genome-wide association studies or GWAS. However, the conventional GWAS, such as linear model and linear mixed model, rely on assumptions such as independency and normality. May not be suitable for the categorical data such as seed code color. Therefore, in this study, we apply the GLMM model to better accommodate the categorical phenotype data.
So in this study, the data that we use is the genotype and the phenotype data from Oriza sativa indica. For the genotype, we will obtain from 3,000 rice genome project that consists of approximately for 404,000 SNPs. And for the phenotype data that we use is seed code color classified as red and white. And then after the after the filtering using call rate equal and above 90% and the minor allele frequency equal and above 0.05, a total of 864 Oriza sativa indica accession we use in the for our analysis. And to account for the co-founding effect, the population structure was controlled using the PCA and the genetic relatedness model was modeled using genomic relationship matrix or GRM. As we can see in the figure below, we indicate a strong association signal on chromosome number 7, and this finding further supported by the heat map.
Okay, applause for team 35. Okay, now we're gonna start the debate session. Please, for operator, set the timer for 6 minutes. Okay, are you ready, guys, for the session? Okay, you can start now.
Okay. Okay, thank you very much. Okay, so could you explain more how do you justify that your data is valid? Do you have any like inclusion criteria, specific inclusion criteria and exclusion criteria as well?
So actually, we use secondary data that the data have been filtered. So yeah, we use only the like binary data from the biotechnology, yeah, something like that. So you just secondary data.
Yeah, because as far as I know, even though if we use the secondary data, we have to make sure that the data will be like uniform. So what the things that you do to make sure that everything is uniformly before you analyze the data.
So maybe we just filtered using like we said before, calling like call rate and minor alert frequency. So We just do that process for our data.
Do you have collect the geographic location data because maybe some wild I don't know, wildlife have some we the rice have some different country like China and Indonesia have a different uh, climate. You know.
So in this study, we only use the Orida sativa indica, which is in Indonesia is the Orida sativa that more common use in Indonesia is Orida sativa indica. So we filtered the data is only the Orida sativa indica.
But you cannot make sure that is there any Oriza sativa indica that actually not from Indonesia.
So actually, Oriza sativa indica is spread not only just in Indonesia, but
In Indonesia is more common is indica, but indica is not only in Indonesia. In China and so on is there's Oriza sativa indica too, but in Indonesia is common is indica.
So you only including from the data from Indonesia, or you actually not dividing into different groups?
no, we use all the data. So the data, 3,000 data is spread spread from all, yeah, geographically from other countries, including Indonesia. So we only filtered the indica sativa, not, yeah, yeah, but we use other country too.
Do you know the location from the SNP have a significant result from the geos like location like do you know the DNA have intron section and exon section? Do you know the location? The SNP result?
So yeah, the location actually, when we download the data from the Rice Genome Project, there is also the like SNPs ID and the SNPs geography the SNP location like that. So in this study, we also like we continue from previous research. So in previous research, they they divide the countries like for cluster. Yeah, but like maybe, yeah, maybe like that.
So you mentioned that you used the previous maybe study, and then can you share us about what is the novelty of your study?
So the previous study that we use only explain about the GWAS, not using statistical method. So the novelty of our research is using a statistical method like GLMM and like,
And then if you use the analytical method, but you cannot control some of the bias, how could you make sure that your analysis is valid?
so actually in this research we control the bias using Bonferroni testing. Do you ever heard that? Oh, yeah. So when we model, when we want to know about the relationship about the variable x with the y, uh, the GLMM model actually produce bias, but we can control the bias using the Bonferroni testing. Bonferroni testing is one of the method.
Okay, give applause for Team 41.
Maaf ya, aku nggak ngerti soalnya.
Is Team 41. Congratulations. Okay, before you go, please go first because we have from our
Mau
judges.
istirahat. Mau istirahat.
Uh, yeah, thank you. Yeah, thank you for Team 41 and 35. what I understand, because this is a debate, so then clarity of your ideas, including when you ask questions, when you respond to questions, should be clear. And I'm not saying that you are not clear, but there is still a room for improvement. The other thing is, because this is a debate, so usually we are encouraged to speak confidently. I mean, speak loudly and convincing, because you want to convince others with your great work. So people will have a less idea about your great work if you don't say it confidently. Yeah. So because even me, I'm sitting at the front. Sometimes it's quite difficult to catch up all the discussions, because it seems that it's only between two of you, to the groups. So I'm trying to listen to the response and also questions. Yeah. Some of the questions to me is very good. I mean, sometimes when we do the debate, we tend to clarify something. It is okay, but after that, we should follow up that questions, that clarification with something that trigger critical thinking from your opponent. Like, for example, when you questions the first one, I forgot. Oh yeah, what is the definition of global apa tadi ya? And then you answer that, and then you question back. If it is not geographically balanced, can you name it as a global? So that's a very good discussion. Yeah, you challenge the critical thinking on top of clarification on something. Yeah, thank you.
Yeah, thank you. I think I want to double down into the technical part, because here we sometimes like apa. Jadi it's a bit difficult to us to grasp what's going on in there gitu ya. And also Bu Ade, I think is really good point, because what I experienced from these two groups is just like a list of questions. So in a debate, you need to build up, right? You need to build your questions, and then what is follow questions until it should be the end of the team at the end of the day cannot answer that. I mean that's a debate, right? Ya sampai nggak bisa jawab gitu kan. Nah, it's not about like you when you have a list of questions and then you ask one and then the other one answers and then another question. So it's like tanya jawab. It's not tanya jawab, but this is a debate gitu. I think it's a good also for other groups. Yeah, maybe you can still think about how to build up your questions on top of the discussion. So it's not like you have list of questions and then you deliver those questions. So yeah, and please for the next group to be close to the microphones. Don't be shy, because we barely hear what's going on there. So yeah, okay.
Thank you. Yeah, thank you so much. I think Putri and Bu Ade really capture it well. Jadi mungkin saya bahasa Indonesia biarin aja ya. Mungkin biar stay in present gitu. Pasti kan di depan tegang sih. Cuman coba tarik nafas dulu. Yang penting tujuannya apa? Small win aja, nggak usah. Yang penting, oh saya berkomunikasi, saya agar lawan saya paham pertanyaan saya. Pokoknya yang penting hal-hal kecil dulu aja mungkin. Dan tadi debat kan harusnya fluid. It should enhance your critical thinking. It's not just for the sake of the question gitu. Karena kan kita sebagai judges juga akan menilai ini pertanyaannya relevan atau enggak. Tadi misalnya pertanyaannya bagus. Kenapa datanya itu valid? Maksudnya apakah Anda merasa datanya valid? Tapi kelompok bentar nih, kelompok 35 kok kurang yakin gitu loh kalau secondary data itu tidak valid, padahal kan sebenarnya semua data mau public data kan you are using public data, right? So you both actually are equal. Jadi sebenarnya tuh kalian tuh punya grounding yang sama gitu. Cuman tadi nggak apa-apa, ini kan latihan to build that confidence. I know like to be confident, like it takes time, you know, and it's a process gitu, nggak apa-apa. Yang penting ini jadi proses pembelajaran aja, but you both did well, maksudnya udah sangat uh, dengan waktu dan dengan ininya, jadi ya ini sih masukan dari kami biar kalian makin sukses gitu. Yeah, thank you.
Okay, thank you. That's wrap the match 2 for today's session. Okay, you can go back to your seat. And again, give applause for team 41 and team 35. Okay, that's conclude our session now. So we're gonna have a lunch and break. So you can come back to this room at 1:30 p.m. Okay? Okay, yes, please. You can get rest and break and also lunch. Thank you. Okay, just prepare after lunch for Mat 7, Team 20 D0020 versus Team D0026. Okay, we can back after lunch. Thank you. Okay, for Mat 7, please prepare for team D0020 and team D0026. Just prepare and we're gonna wait until 1:30 p.m. Okay, just for prepare for operator 2 before we start match 7. Okay, now before we begin, should I again to remind the rule of this match? Okay, so before we begin, maybe you can switch first or just by your agreement. No? Okay, agreement. Will be the first presenter, and then after that, we're gonna give 3 minutes for team depender to do the present your idea, and then after that, we're gonna give 6 minutes for debate session. And debate session, you can debate each other, move back and forth, and then 30 seconds for team attacker to attack the team defender, and team defender just have time 1 minute to defend your idea. Okay. It's depend on your question. As long as your question is short, so maybe you can have more time to do the debate session. Also, your answer, maybe your answer not too long, so you have more time to do the debate session. Okay, we can start. Okay, so based on agreement, who will be the first presenter? Oh, okay. Please prepare for team 26. Sorry, maybe you can adjust the time. Sorry, the ID team first, operator. So, in the left me is team D0026, and the right one, team D0020. Okay. This one 26. Kebalik, yeah, will be just by our operator first. Oh yeah, boleh. It takes time to operator adjust the team ID a little bit. So yes, the team will switch or move their seat. Oh, okay. Yeah. Waiting for that. Okay, it's clear enough for judges too. Maybe you can. The first presenter is team 26. Please prepare for the 3-minute slide. Yes, left 26 and right 20. Okay. Tell me if operator was ready. Okay, it is yours. Okay, are you ready for team 26? Yes. All right. Okay, for 26, you can start now.
Okay. Our study about the phylogenetic group distributions and virulent genes profile of clinical Escherichia coli from West Kalimantan. And next. Oh, di belakang posisi itunya. Oh, ini.
We can. Okay, set the timer for 3 minutes. You can check it first. It work or not. Nggak bisa. How about operator can next. You can help. Okay. Okay, please set a timer for 3 minutes. Operator. Ready? Okay, for team 26, you can start now.
Okay, our study about the phylogenetic group distribution and virulent gene profile of clinical Escherichia coli from West Kalimantan. Next. Antimicrobial resistance. Now the most urgent public health threats that we know that 1.27 million that attributed to AMR globally in 2019 and 97,000 deaths in Southeast Asia alone. Escherichia coli is one of part of that crisis that from previous study show that the resistance to cefuroxime reach 85% in some settings. Also, they have some virulent genes, and the challenge is ESBL producing Escherichia coli strain are increasingly difficult to treat, and their virulence and resistance profile are shaped by their phylogenetic background. Yet in Indonesia, particularly in West Kalimantan, there is no local molecular data. So to fill the gap, we aim to characterizing the phylogenetic distribution, virulent genes, and antimicrobial resistance pattern of clinical Escherichia coli in West Kalimantan. Next. Our study conducted in Dr. Sudarso General Hospital from Pontianak from June to December with various specimens. We are doing the identification and susceptibility testing using BD-Poinix, and we are doing the genomic DNA extraction using Presto Mini DNA bacterial kit, and for confirmation, ASBL gene detection, phylogenetic grouping, and also virulence gene profiling using RT-PCRs. Next. Our results show that the 100% resistant to ampicillin, cefazolin, cefotaxime, and also high resistant to ciprofloxacin and cotrimoxazole. And from this study show that the carbapenem group, meropenem and imipenem, still high susceptible. Next. From the molecular detections, the virulent gene profiling across phylogenetic groups show that the phylogroup group B2 and D show the most virulent gene found in this population. And our conclusions, next, show that the carbapenem remains highly epitic, though emerging resistance is concerning. CTXM as the dominant ESBL gene across all phylogroups, and phylogroups B2 and D harbor the more the virulent gene detected than other phylogroup. So this finding highlight the need for antimicrobial stewardship and molecular surveillance to control their spread. Thank you.
Okay, thank you for team 26. Okay, now we're gonna start the time for 6 minutes for debate session.
My
30 seconds? No, not yet. Not start yet. Okay. Okay, 30 seconds for you give your attack and 1 minute to give your defense back and forth for 6 minutes. Okay, for timer. Okay, 6 minutes for debate session. You can start now.
My first question is, you also using one site, and you said it is OS Kalimantan, so it is a limited data. So instead of using the limited data, it represents a lot of in Southeast Asia where you don't have to do a lot of collaboration with other sites, which is might be more competitive and robust to be calculated because it is limited data.
Okay, thank you for the questions. We use exactly we use only one hospital. That this hospital is our provincial that our provincial's general hospital that show that from the other part of the West Kalimantan use this hospital as the first primary hospitals.
Okay, this part, as mentioned used before, because of the part and its limited data, does it like really reproducible, and how we can we reliable if you said that it's also West Kalimantan?
Okay. Maybe not mentioned in the study that our samples is from some of from what's regency from West Kalimantan, the samples itself. But the samples itself maybe from the June to December also still limited. Reproducible. The about the reproducibles about this data. Uh, maybe the data maybe still limited, but this data give the representative that to describe to uh,
Okay, you said that it's reproducible. Why? Due to the limited data you get, it is 120 installation if I'm not mistaken. Why you don't like gave it like external validity to your method? Because it's I guess it's really possible instead of like using use it alone it your lab. External validations,
such as
you check the under lab. Is it like a real exterior scholarly or not, or the
Okay.
same? Yeah.
To the external validity, we use the ATCC confirm isolates that this is the general for to confirm all isolate over the world. So we use the ATCC isolates for the external validations.
In your lab?
Yes.
Okay, I mean like the external validation is you check the your certain microorganism to other lab. Is it confirmed that is the real Escherichia coli that it's suitable with your what is it like method? Yeah, like your method as well.
Actually, we use two laboratory to identify the isolates. First, from the laboratory from General Sudaso General Hospital to identify using BD Punix. To identify using BD Punix tools, and we also use housekeeping gene CAIO that's confirm this isolate is E. coli. And also we use the phenotypic confirmation using Eosin methylene blue agar to confirm that this isolate is Escherichia coli that show the green metal exchange from the colony.
Okay, this is a quite interesting topic related to the region specific area. And you mentioned that you said that the carbapenem or ipepenem, it's really what is it like in your area is high. So what is your suggestion for the clinician?
The suggestion from the clinician is the first is about the antimicrobial resistance that we can see from the result that almost 12 antibiotics has the lowest susceptibility or highest resistance, and also only from group carbapenems that only resistant that only susceptible. So it's in line with this result because the ESBL group is formerly uh, uh, attack the beta lactams from the antibiotics. So, which means that only carbapenems not can.
Okay.
Okay.
My last question is: this is a really concerning public health concern because if you're using the carbapenem in that population, it will lead the antimicrobial resistance, which is lead in the population. So it is also like a tricky thing. So it might be useful for the policymakers. So what do you think about that?
Okay, our study goals is to how we can make the better policy. First, because we do this in hospitals, so the first line that we can ask the clinician to adjust their therapy for their patient as what we have found in the study. And the second, we can change the hospital policy based our study. Also, the global.
Okay. Thank you, Virgin Presentation. Now, the score now comes to the screen for team 26, 7. For team 20 is 8. Okay, we're gonna go to round 2. So, please prepare for team 20. Are you ready? Okay, for team 20, the timer, please set the timer for 3 minutes. Okay, and for team 20, you can start now.
Good afternoon, everyone. We're from Team D20, and this is our research. Next. Cervical cancer remain leading threat in women health despite being preventable. Recent screening such as HPV or cytology often diagnose, overdiagnose or misdiagnose. So we need to improve this diagnostic. World Health Organization has been pointing out that DNA methylation can new direction for this testing. Why using DNA methylation? DNA methylation can underlying biological change, so it can distinguish which HRHPV positive woman can are ongoing underlying in this are ongoing progress in cervical progression, especially in cervical dysplasia. So we aim to know what kind of methylation signature in this patient, so we can distinguish between this stage. Next. So our methods is integrative analysis. In this first one, we do some research, search for database on geo database. We got 4 data set, and after that we do some pre-processing and statistical analysis, and also gene ontology to know what kind of pathway that come from this list. Next. So this is our result. In initial probes, we got 100,000 probes, but after we do some annotation, filtering, and statistical analysis, we got 1,000 genes, and after that we got differently metilated genes, and finally, after we got gene ontology to know what kind of pathway that can distinguish this cervical dysplasia stage, we got 2 hypomethylated oncogenes and 2 hypermethylated tumor suppressor genes. Next. So in our conclusion, our approach can distinguish, can identification methylated signature in HR-HPV woman, addresses limited on current screening, lack of specificity. We got DNMT1 and WT1 as hypermethylated tumor suppressor genes and hypomethylated oncogenes CSV1 and BCL12. While this finding is promising, we also need to further validation before clinical implication. Thank you.
Okay. Okay. Is that? Okay, thank you for the presentation for team 20. And now please set the timer for 6 minutes for debate session. Okay, are you ready? Okay. Okay, Sip. We can start for debate session. Start from now.
Okay. maybe for the first questions is about why you choose the methylations besides the other or mutation or other to be your biomarker.
Okay, we choose methylation because methylation, especially in proliferation cell stage, it can adjust how and which one gene that need to transcribe or not. If a methylation different from normal stage, it can make those gene doesn't transcribe and down regulation in protein expression.
Okay. Uh, how about the mutations? If you use mutation,
Mm.
the mutation itself show that only found in the different cells, abnormal cells, or
The mutation in abnormal cells.
why you choose the methylation
Oh.
over the mutations
Oh, okay.
or other methods?
Okay. Why we choose methylation other than mutation? Because mutation only will doesn't have to does mutation only can be transcribed if those methylation also change. So methylation as epigenetic change will influence those the transcriptomic protein.
Okay, from the sample, it is said that you use the HPV positive precancer lesion, right?
Yes.
So, but the aim of your study is to look for the biomarker.
Yes.
Is it that HPV positive can be the bias for the result?
Okay, HPV positive can be biased because there's you also know that low risk HPV and high risk HPV, and this HPV only can be cervical cancer progression if persistent in 10 to 15 years. If those people in next year, if 1 year they positive and next year they didn't have a positive HPV, they can be suppress those immune effect on HPV, so it can be biased.
And also we just like also divide it into the low HPV and high HPV based on the the special classifications due to like progression. So yeah, hopefully it can little bit like clearly divided between the experiencing gene or that group. Yeah, it's also improving the certainty.
Okay. So the HPV positive is high risk HPV and low
No,
risk
high risk HPV in this
in
our
this study
research.
is
Yes.
high risk HPV. Okay. So you also mentioned about the um epigenetic switch, right? So I mean how that epigenetic switch can driving to HPV infection to high granulation. So how about the HPV oncogen itself, A6 or A7?
HPV, yeah, oncogen is love. Okay. Actually, on high risk HPV oncogen, when they first come to cervical cell, they will be reproductive to make more self, make reproducible itself. So they will uh, alteration those host cell to make more HPV DNA in other cell, impacting other normal cell.
I mean that is the biomarker that you found in the study is have a correlated with the A6 or S7 oncogene. So it's not a stand by her by itself the biomarker.
Oh. No, we only focus on HRHPV. We didn't filter which these HRHPV positive are A6 or A7.
Okay. So from we think this is a good study because we try to find a biomarker. So from the result, what could the study impact to the policy? Is it as a replacement detection or what?
Okay, this is like to improving and give the other perspective of the screening itself, because during our research we focus on the cervical changes instead of HPV genotyping, which is people who got infected by the IVP are not directly changed into the cancer one. It's the process like to change the cervical dysplasia from CI1 to 3, and we classified into the low grade and high grade, which is it will be yeah, yeah, our current research find the motivation, but it's the implication next one is to find out the progression.
So yeah, it's improving the diagnostic, especially as HRHPV positive doesn't mean that will be cervical cancer progression.
For the last question, maybe about the result, how representative your data for data sets for the Indonesian population or yeah, yeah, yeah. Yeah.
Okay, so okay, okay. So for Indonesian sample analysis, because this is wasn't
This is like from data sets, which is we also doing the like align it into the statistic. We using the also like a meta analysis for the transcription itself. So if we have like a lot addition of data set, uh, the is really expected to consult the consistent result. So um, this is like our novelty of the statistical itself.
as you know, on viral infection, especially in cervical cancer, there's no barrier between ethnicity. So I think we can.
Okay, give applause for team 26 and 20. Oh, so the winner of this match is team 26. Okay, so we go to give the feedback maybe from.
Great job of both of the teams. You did very well. I know it's very anxious to to speak and explain your research. Maybe one of the things that I want to highlight that you asked like what does it contributes to Indonesia, and then you answer the statistical analysis. It's and it's
Yeah, it's
novelty.
not related to ethnicity because it's not related to ethnicity because we can use it into the world populations.
Oh, so you think that it can be
Yeah,
generalized to other population?
yeah,
Then
world population actually.
oh, okay, that's quite huh. But Bu Putri gimana? What do you think? Like, do you think? Oh, you know, but no, but we are very curious actually because it can help like as a clinician also, right? Like, yeah.
So to make it precise to world populations.
Oh, yeah. Oh, yeah. Thank you so much.
Maybe September, there any global genes. So what we call before is local optimum, specific from apa namanya local specific populations. But then here we try to find global optimum. It's the same as meta-analysis when you try to aggregate the study, right? When you try to pull all information from different studies and then this is the apa itu namanya cumulative information from all studies. So basically this is all about the study. Gitu. Jadi bisa premisnya adalah bisa apply ke semuanya tapi memang belum clinically apa validated gitu.
So maybe the important message is your study is amazing, but sometimes we as people who doesn't understand like how to communicate those novelty, right? Because if you have those novelty, but I couldn't understand, how can I appreciate the
True.
greatness
Yeah.
of the
Yeah.
study?
Yeah. So maybe as a feedback from the team 20 D20, instead of apa namanya present about the DNA methylation and also the cervical things because yeah maybe about maybe about the what's the difference between the study, maybe also apply to other teams ya. Gitu. Maybe for the general knowledge or general information.
Confident with this tool, just yeah, you can easily respond to such questions. I'm also happy to learn that each of the team, when you some of your questions is beyond clarifications, yeah. Sometimes you challenge the opponent by providing other potential approaches, whether your approach is better atau you miss to look for other potential approach tadi ya. For example, why methylations instead of mutation. So whether or not you estimate there is a potential bias and such, yeah. So, but thank you very much for the work. I give back to.
Yeah, before you go back to your seat, I will inform you to just prepare your snack match for team 20, team 20, 26, team 20. You will match again in this room too after 4 match after that. Okay, 4 match after that. Okay, with team loser from match 8. Match 8, 80, match 8 on room Arjuna.
Oh, masih.
Okay, masih berlangsung kan. Okay, so for team 26, you will match to room Arjuna 1 after 1 match after this. So maybe you can prepare there. Okay, with team 81. Yes, 81. That the same sensei? Yes, because
okay, yeah.
yeah, it's okay. Okay. Is that okay? Give applause for team 26 and team 20. Thank you for a nice debate. And now we're gonna move to the next match. For next match, I will invite for team D0060 versus team. Who's the winner for this team? Team. Aku nggak tahu lagi. 2079? Oh yeah, just wait a minute. Yes, I will invite for team D0079. Please come to this seat. For team 60. Where's team 60? Okay, team 60, you can sit here. And for team 79, please get your seat here. Where is team 79? Okay, we will waiting for team 79. Iya, ketinggalan date bangetnya. Halo, Bapak? Can you call for team 79? Because oh, team 79. Oh, okay, okay. Okay, you can get your seat here. Okay. Ya, nafas dulu, Bu. Okay, for team 60 and team 79. Maybe you can switch first to decide who will be the first presenter. Or by agreement, ladies first or boy first.
Tunggu di kertas.
Okay, ibunya menang. You will be the first presenter or you will give them go first. Okay. For team 60, please prepare. Team 60, please prepare the 3-minute slide. They will be the first presenter and they will be team depender. No. This one for camera? Yes. This is yours? Okay. For team 60, please set the timer for 3 minutes. Okay, are you ready? Yes. You can start now.
Okay, okay. Good afternoon, dear honorable judges, all the committee, all the participants. So, before I running our presentation, let me ask you one simple question. If we know that smoking causes various health problem, so what is this the condition of the farmer of the tobacco farmers because they are in direct contact with the tobacco plants every day on many years. So, uh, let me and in this sorry, can you go back? Oh, okay. So in this opportunity, I'm Gergis with my teammate Ayman will going to present our current result entitled P. So green tobacco sickness is caused by transdermal absorption of nicotine from wet tobacco leaves and from the and also excessive sweating. And interestingly, globally, one out of four tobacco workers, especially in women, bearing a higher burden compared to men. And moreover, in Indonesia, especially about 87% of the tobacco workers is inappropriately in wearing the PPE or personal protective equipment. However, the PPE or personal protective equipment is the strategy for preventing the dermal nicotine exposure. Therefore, our research study Therefore, our objective of the study is to assess the association between the PPE compliance level with the clinical of GTE's toxicity patterns and cardiometabolic profile in tobacco farmers in Temanggung, Central Java. So, to perform this study, our study design is an cross-sectional study were conducted in Temanggung Regency, Central Java in 2024. So for the result, as we can see here, yes, this one is so the socio-demographic characteristic. And the interesting one is the largest proportion of respondent was about um, more than 8%, 80% was the person who was already worked in the tobacco farmers for more than 10 years. And the another data also suggests that the female are demonstrate a significantly higher average of knowledge and practice score. However, most farmers had been engaged in tobacco cultivation for more than 10 years, while knowledge scores tended to be lower among these long-term farmers. Moreover, our association between
Time's
the PPE
up.
compliance.
Okay, thank you for team 60. Okay, now please set the timer for 6 minutes to debate session. Okay, 6 minutes. Okay. For team 60 and 79, are you ready? Okay. Okay, for debate session, you can start. Need open my timer first. Okay, you can start now.
Okay, thank you for your presentation, and the topic is so nice. My question, the first question is, your research used the cross-sectional study. So how can you justify any causal relationship between BPA compliances?
Okay, thank you for the questions. Speaker, the question is about the justification of correlation between PPA and GTS, right? So we found in further analysis using T-square and also Pearson analysis, we found that GTS or green tobacco sickness is significantly associated with female sex again or gender is mostly by female, and also it's also correlated with employments, which is more than 10 years, and also working time more than 8 hours. And also there's an interesting findings that smoking is paradoxically uh, affects the GTS symptoms, which is the non-smokers is more vulnerable to GTS sign and symptoms. And also for the metabolic markers, triglycerides is found significantly corrected with GTS.
Yes, thank you. But we know that the cardiometabolics like blood pressures and then a lipid and so on, it's can describe about our healthy profile in 3 years, in the latest three months. So how you use the what cross sectional to uh,
Okay, so I think about the cardiometabolic and with the cross-sectional methods, right? So we just use for the cross-sectional models due to limited time, and also we want to what is it to explore about the what is it about the current socio-demographic, especially in the carotid disease such as hypertension, hyperuricemia, and hyperglycemia, and also dyslipidemia.
Okay, a little bit added. So this is because like a pilot study. So we also plan to like work with more study and more participants. And maybe thank you for your suggest. Maybe it can be like for the next study. Maybe we can decide to work with the core study to yeah
okay.
to more.
Yes. Thank you.
Yeah, because it is also like an interesting research because we can provide for the like policy.
Okay. The next question is how do you control the confounding factors of this research? Because like the cardiometabolic factors is maybe influence of the risk factor, the other risk factors like the daily activity and then in nutrition intake, and maybe in the moment is have the CS as a negative smoker. How do you control confounding?
Okay, thank you. So for the confinement controls, in the first at the study design, we already checked for the previously study related to the tobacco, green tobacco sickness, which is there are also some study in Indonesia, but they are more related to the study or explore about the like the current condition, and they also use the same study design. So that's why we also use, and also some of the like international published paper work that those study are work in like the Latin America, they also work with the design method. So that's why we also prove this as this our met design met study design for the cross sectional study, and also because we also want to ask seeking the correlation between the PPE and also the other factors like the green tobacco sickness toxicity patterns and also the cardiometabolic. So that's why we also add some more blood.
Okay, thank you. Every the research have a limitation. Yeah. Can you tell me about your research limitation and how you appreciate anticipation for your
Okay, thank you for the question. So about the limitation, as mostly of the cross-sectional studies, the limitation is about the sample size, which is it's only using for one regency in Indonesia. So I think it's more proper to conduct further studies with high, broader sample size. That's the first. So, but the our anticipation, we use the PCA and MCA analysis for multivariate analysis to find to look for the association between the outcomes and also GTS based on knowledge and also PPA practice.
Okay, thank you. The next question is uh, about sample size. Out of 155 participants, only 44 completed the examination like this. So, how do you address for the potential bias and reduce the statistical power?
For actually we also test for 100, but most of the data because we are using the commercial kit, so that's why more of the data is like cannot be used because the monitor saw the data is too higher or too lower, so it's also like the limitation of the monitor rapid test kit that we are using. So
Yeah, I think the limitation is not it's randomly occurs for what is it for the errors instrument errors. So we think that we do not have selection bias because it's errors is randomly occurs across the populations. Yeah, across the statistical analysis. Thank you.
PPT from 79. And you can take your score now. 5 for team 60 and 11 for team 79. Okay, just wait for the next slide. Okay, this is yours. Okay, are you ready? Good.
Yes.
Okay, set the timer for 3 minutes.
Okay. Thank you for the time.
Okay, you can start now.
Thank you for the time and the honorable judges and all the participants. I will explain about my research. The title is Can Digital Antenatal Education Improve Maternal Health Practices? A quasi-experimental study. I'm Christine Dewi and my partner is Ibu Umaro. Next. Why? Because why we have the research is this pregnancy is a critical period, so this proper antenatal care is practices are essential to prevent complications. However, adherence to recommended ANC practices remains suboptimal in developing countries, including Indonesia. What's the problem? This is a low adherence to ANC practices and limited reach of conventional antenatal education. So we need for innovative and accessible intervention. Next. Why digital-based education? Because this is flexible, accessible, and scalable, and enhance knowledge and health behavior. So they have high acceptability among pregnant women. So what is the objective to evaluate the effectiveness of digital-based antenatal education in improving antenatal care practices among pregnant women? Next. For the method is quasi-experimental pre-test post-test control group design. The total sample is 170 pregnant women. And this is conclude a sub-district purposefully selected as cluster units to minimize contamination bias. And for weeks, digital intervention delivered by trained midwives and component is digital modules, videos, interactive discussion, quizzes, and peer sharing. And the instrument is facilitated guidelines, digital module, and instructional videos and data analysis using independent test and GLM-RM. Next, how to minimize bias access, extract material access through workshop features, use indicators like message info, like read or delivered status to monitor whether participants have opened the shared materials, and then create an access monitoring list, follow up the gentle reminders, and use the short quizzes to confirm engagement. Next. This is the consort flow diagram for sampling process and cluster, all our 17 sub-district. And for the intervention group is 9 sub-district. And this is 10 respondent each district. So the respondent in the intervention control is 90 and the control is 80 sub-district. No loss to follow up. All participants completed the study. Next. This is the result distribution of the characteristic, the age, education, occupation, and number of pregnancy. Next. This is the central tendency and effect size by Cohen-D. And this is the GLM-RM test result.
Okay. You didn't finish the presentation results. So what's the main findings of the key findings of your results, and how it's implicate the community or maybe public sectors? Thank you.
Okay. Yes, the main finding is that digital antenatal education is have high impact to improve the maternal health practices and include the antenatal care practices and then nutrition fulfillment in practices and peace activity, daily activity practices during pregnancy. And this is a very implicated because uh, in the public health, antenatal conventional antenatal class is like the face-to-face class is many barriers like the time and then but the barriers is uh, time to work. So the pregnant woman can attend it the antenatal class, and then the the distance from home to public health.
Okay. So as we can saw, because in your result show that most of the participants was or the age of the participants was about 27. But have you ever concerned about what if your idea or your project can be adopted to the like the old woman who also still have the condition to be or ability to have the pregnancy condition?
Okay, this is digital alternation is use the common sources like the WhatsApp group, so we can share all of the material like antenatal module in apa module videos and then quizzes in the interactive discussion we can do in the class by WhatsApp group. So this is the I think every 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 time and then every respondent is commonly use this yes, use the use the canal using the WhatsApp group.
What my question is, do you ever concern about the age of the study population that included in your study? Because as we can see in your result that most of the participants, the age was about 27 in the intervention and about 28 maybe in the control group. So do you ever concern about if this result can be implemented in the society? How about the willingness of the like the woman who already in the old age but they still need to teach others
Sorry, because this is we have the role of the pregnant woman that's reproductive health is less than 40 years old. So I think the pregnant woman in the mostly the pregnant woman is under 40 years, and I think in uh, in a current situation is in the current situation as the commonly in the real setting every woman every woman's like a pregnant woman is use the WhatsApp group. So I think this is
okay.
Okay. I would like to ask about the follow-up questions. How about the total of what is it? Pregnancy. So it's mostly like 27 or 28 is the first pregnancy, right? Is there any what is it uh, significant effect of the for the second or third or later on? And the maybe this first.
uh you can say yes yes.
Okay. So the question is about the primigravida or multigravida. Is it
Yes.
affects on the this the utilization of digital education, and also how do you monitor about the post test what is it assessment that the participant they didn't was it look for the material while they assess the will complete the assessment.
Yes, for the post-test is post-test we have two post-tests, as one is the fourth week we finish the intervention and the post-test one, and then 2 weeks later is post-test two. So we just want to know how deep they can uh, to retention information about the material of the antenatal class. So the primigravida and then the multigravida.
Okay, thank you.
So a great job on the two teams. So we learned that sometimes you are good at asking question, but answering, like, I think like you have difficulties is answering the question from team 79. For example, team 79, you ask a great question like, why is cross sectional? Why your studies using cross sectional? Why you cannot have any association, right? But you didn't answer the question. We feel like you didn't explain it clearly, three of us. Like, okay, like you explain it not answering the question like why it's why the conclusion doesn't have any association. But yeah, that's, and the second one I think like the team 60, yeah, team 60. I think you asked a great question about why is the target population is not older women. One of the things that you asked, and but I don't get the answer also, like why you only involve 27 years old in the studies, the average, but what is the criteria for your studies? Reproductive health. Okay, so your concern is because of their reproductive health. Like when you answering those, like I don't feel like I get the answer. Yeah, but I think like if you answer it, yeah, because the time and also the anxiety, of course. But I think like if you can answer it clearly, addressing the question, I think it would be great. But both of the studies are really great. So thank you. That's my. Oh yeah.
Yeah, okay. Yeah, despite of what the judge said previously, that I appreciate apa ya the clearness of the presentation, even a bit overrun gitu ya for the presentation, but it's getting much better the way the teams, I mean the previous teams as well to present, and also how to articulate the questions and the answers. Yeah, so maybe a bit comments to team di 60 gitu ya. Your study is about cross-sectional study, which really different with the RCT, right? But the way you answer it is like you are not confident with the observational study, but it's totally different with RCT. You mentioned about bias. Actually, there is a apa namanya a way to tackle bias in a cross-sectional study, and also when the attacker mentioned about the apa tadi power ya, about about apa ya, something about power. Um, Actually, you can answer it with the you should have done sample power calculation before, right? You should have that. You should remember that, and then you should answer that question with that result. So I think actually your study is apa ya, is totally different with RCTs, and please be confident even it is not randomized gitu ya. And also you should have known how to tackle the selection bias. in a observational study. For example, with propensity scores, or maybe with other scores as well. Okay. Yeah. And also a note that sometimes I observe both of the teams answers differently with what what the other team ask gitu ya. So maybe I think if you pay attention to that, it can be your chance to bring down that team, right? But I don't apa see that you use that chance gitu. So sayang gitu ya. Sebenarnya so actually each of during the discussion or during the debate there's some chances to bring down the other team because you are both not not answer the real questions, but no of the team use that chance for it. So maybe it's also good for the next team when you are in a debate gitu ya. Yeah, so maybe that's yeah. And also I have a note about the apa namanya sample size. When the team D60 mentioned about the sample size, you should have mentioned that as a limitations if you already declare that your apa namanya result is from that for that area gitu ya. Maybe the limitation not about the sample size, but the question is about may not be generalized in other area. But actually the sample size itself, if you already state in a title, you specific in that apa district or whatever apa namanya level it is, so it should have been the limitations. So I think a bit sayang gitu because in some of the your statement you bring down your own study. Yeah.
You believe
Yeah, gitu. Okay. Silakan.
Yeah, thank you for the two groups. If I know that you are aware that two of you like you cannot finish the presentation. Yeah, you just arrived to the initial result and the time is up. So meaning that for your next round, please make sure that you are aware that the time is only 3 minutes and it is very short. Yeah, yeah. Most of you spend so much time in the introduction, so you miss the chance to present the main findings. The second is, yes, I agree that some of the question, especially about the study design, was not adequately response to the groups. While actually you can, yeah, you can, because there is nothing wrong with the cross-sectional as long as your claim is for cross-sectional. When your study is cross-sectional, but you claim as the causal relationship, then it's not okay. But as if your claim is really for cross-sectional study, there's nothing wrong with cross-sectional study, yeah. And then I'm happy that in the group there are so many follow-up questions. So it is not listing down all the questions. Okay, next questions gitu ya. For example, like your questions, it seems that your approach is for the young pregnant women because the average age is 27. And how if do you think it is still relevant for the older pregnant women, because in the real setting we still can find women above 40 who is still pregnant gitu ya. Although it may not be your case for your study, tapi in the real situation a lot of women above 40 masih pregnant, whether or not it is still relevant. And he also questions you next by asking questions. It seems that for the 27 years old pregnant women, they are in their first pregnancy. So what do you think if it is for the second and the third pregnancy? That kind of questions is very relevant. So it's good to know that this debate also already have, ya bagus gitu debate-nya ya. It's not only listing questions. Yeah, thank you.
Okay, for the winner of this match is Team 60. Congratulations. Okay, you can go back to your seat, but before that, I will inform you Okay, for next match, match 13. Please prepare for team 51 and team 80. Ya. Sampai yang mana? Sekarang kita
Match
di mana?
13.
Ya, kita di match 13. Match 13. Betul. Masih banyak. Oke. Team 51, right? Okay. For the right one, team 80. Okay. Finally, Pak Moses, you again. Okay. Okay, who will be the first? You wanna switch or yes? Oh. Okay, you winner. So you want to go first, or you will give them their chance to go first? Okay. So for team 80, we'll go first. Please prepare for the 3-minute slide. Okay, this is your Pak Moses and Bu Jayanti, right? Okay, for team 80, are you ready? Please set the timer for 3 minutes and you can start now.
Well, our research title, Humor as a Psychological Buffer Against Distress Across National Study of University Students in Indonesia and Malaysia. Next. The problem is students from university are increasingly vulnerable for psychological distress, academic pressure, financial strain, social transition, and etc. This phenomenon contributed higher level of anxiety, loneliness, emotional, etc. Next. Well, we found out that humor has emerged as a promising strength-based protective factor that may enhance cognitive reframing, emotional regulation, stress recovery, and social connectedness. This is the question. Can humor work in South Asia? Or it still is a limited evidence base? Next. This is our research questions. Does humor can help students to overcome their psychological problem, distress, and well-being? Next. And this is our aims. The study examines humor can increase student well-being and lower psychological distress amongst university students. Next. This is our method. Design participants, cross-sectional design using 282 participants. We have 3 instruments: scales, humor quotient, psychological distress, and well-being. Well, statistical analysis, we use error studio, Jamovi analysis, Cronbach's alpha, confirmatory, and structure equation model. Next. Well, this is the results. We found out that a weak positive association between stress and humor scores. This is quite weak. And then the second one, it's promising. We have found a weak positive association between psychological distress and humor scores. And the scatter plot analysis demonstrated a positive association between stress and well-being scores. Next. This is our conclusion, that we answer the research questions. Humor has a limited protective role to distress and well-being. Distress and stress are more consistent predictor of well-being, although unexpectedly positive relation with well-being. Yes, this is like an arc or a gateway for research, but it requires further study. And this is a promising study that can be intervention, efficient, cheap, and can be generalized for all Indonesian and Malaysia. Well, my friends, next. This is my last slides. Then I still have 5 seconds. Thank you very much.
Okay, thank you. Okay, thank you for very nice presentation from Pak Moses. And now please set the timer for 6 minutes for debate session. Okay, are you ready? Okay, maybe. Okay. Start the timer for 6 minutes and start now.
Okay, thank you. Very interesting, Pak Moses. So I want to ask first is how can you quantify humor?
How? thank you for the questions. How you can quantify the humor by the perception of human perception. I mean, how they give answer to the perception of like our questionnaire humor scales. Then we know the quantify the humor.
Then I saw in your study you didn't categorize Malaysian and Indonesian students. Do they have a same or similar humor quotations, quotient, something like that? Humor score? I mean, like.
Oh, score.
Yeah.
Well, that's our strategy. Don't show the data. And I'll tell you the data then. We have 195 female women in this research and 87 male. And from the Malaysia, there are 153 from Malaysia and 129 from Indonesia. From where that's from University Technology Malaysia in Malaysia and UNER, that's 129.
Okay then. So then why you use stress and distress for the category in here? What is the difference?
Okay. You asking about the definition of stress and distress. You know, is that your questions?
Why you use stress and distress?
Oh, why? That's the problem. I already saw you in the previously explained that in academic atmosphere, there is a problem in student. What a problem? Psychological problem, stress and distress. What happened? That they have a problem on that, and we looking out which intervention can lower their psychological distress or stress and grow up their well-being. That is why we choose stress and distress.
Okay, maybe my question a bit related with previous question from. So we didn't see much data in this presentation other than the graph, because you mentioned that that was part of your strategy, but I think that's make us a bit confused because we don't know how you draw the conclusion, because as we can see the graphic and the data is very scattered, and so how you can draw the conclusion that there are some relation between the variables that so you can draw a conclusion that this affect this and this help this. So how your process?
Oh, your question is I don't know your data, so how can I know that this is valid or reliable? Is that your questions? If that's so, I can explain your data then. All right. Well, I as I already told you that we have 282 respondents or samples, yeah, and then from that samples we run the analysis, Chromebus alpha, confirmatory, and then SEM, and we found out that from humor to well-being, the regression coefficient is 0.509. The p-value is 0.062, and the determinant coefficient is 0.012. The second regression from the humor to distress, the coefficient is okay.
Okay, why I was asking that is because we can see that from the graph, the data is very scattered. Like there are no categorization in those data, so we kind of how to say it? It's hard to us to imagine how you draw the conclusion, because you also show some linear regression that supposedly show relation between those variables, but the data is very scattered. Also, I maybe want to ask: is there any possible explanation about this? Because is there any possible Hawthorne effect that happened?
Oh, okay, thank you. Maybe you have see our figure 1, 2, and 3. There's an axis, X and Y. Do you understand how to read that? There is a number of that. Is it you saw that?
Yes, we saw that, but because you used like a total humor, if I'm not mistaken, that's also a bit confusing for us because humor is very subjective for us to think. So how could you quantify that? That's the first question. And then the second one, even after you quantify them, the data is still very scattered.
Yeah, thank you for the questions. When we have a stress or distress, how we can quantify the psychological condition? We show you the instruments. That's the instrument can reveal what happened inside the psychological condition of that respondents or samples. I think all psychological study use that. That is a very obvious that you say that humor cannot be quantified. I think you can go to the psychology study and read or find out that it can be.
Okay, thumbs up. Okay, that's for the first round. We're gonna move to the second round. So you can look your score now. Okay, for team 51, 10, and for team 84. Okay, so now you will be the presenter. Are you ready? Okay, set a timer for 3 minutes. Okay, you can start now. Okay, so I will present to you our research that have the title Metagenomic Profiling and Bioprospecting of Microbial Protease and Lipase from Fish Processing Wastewater. Next. Okay, so fish processing wastewater is kind of like a gold mine for enzyme with high activity. So imagine it like a cave of wonders filled with golds and magical stuff. The fish processing wastewater is enriched with protein and lipid that become a substrate for microbial life and supports them to thrive. These bacteria could produce some enzyme, and in this case, protease and lipase that could be used in various applications in industrial and biomedical, such as for anti-inflammations and also for dyslipidemia. Next. Our study used both non-cultural and culture-based method, and from the culture-based method, we managed to isolate 6 bacterial strains with both proteolytic and lipolytic activity. Some of them shows an index above 2, which is considered high, and our main character here is the Proteus GB itself with such as high proteolytic and lipolytic activity from the assay that we done. For the analysis using whole genome sequencing, analyze their genetic makeup and show us some of the genes that may probably play a role in extracellular enzyme secretion, and in this case is ceralisin metalloprotease and phospholipase A1 gene. Okay, next. From the non-culture based method itself, we know the community structure, and also we found that the isolated strains are part of the gamma proteobacteria class that were detected in both inlet and inlet basin and sediment samples. Produce CBN itself accounted of 0.09% of all metagenomic data that we got. Okay, next. So just like any other hero story, as much as we like to our hero to save the day, we can't forget that they sometimes have a dark side. And in this case, the dark side is Proteus TB opportunistic pathogenic nature. So for the future work, we'll involve some designing of recombinant factor for expression in grass species in order to safely and sustainably producing enzyme in mass producing scale for industrial and biomedical purposes. I think that's all from me. 51. And now please set a timer for 6 minutes for the next session. Okay. Okay, are you ready?
Yep.
Okay, you can start now.
Well, thank you. As a good and honest researchers, you will wear your Achilles heels of your research and disclose it honestly. Due to the risk bias, internal validity and external validity, do you consider that those significant, crucial exist in your research? Could you explain that? What do you say?
So I will confirm your question. You mean that is our result valid? Something I didn't get any. Actually, I didn't get your question because it's too flowery.
Yeah. Do you know the Achilles heel?
Yeah, I know.
Yeah, I know. So
Yeah.
your weakness of this research. Then my question, as you consider that this is research, have a weakness of that, and what weakness of that? Internal validity, external validity, and also the risk bias. Thank you.
Okay, so this is actually the exploratory study. So the weakness, actually the weakness of microbiological research in general is you cannot catch every microbes in a sample. So we use two strategy in here, the culture-based strategy, where we catch the actual bacteria with the enzymatic, the lipase and protease activity, and also see the whole bacteria in the sample using the non-culture base, using the next generation sequencing metagenomic. We catch all the DNA, and all the DNA say, oh, who has those DNA. So in this case, we try to cover as much as ground as we can to cover the weakness of our study.
Okay. For the second questions, I want to ask to you about your samples were collected only from inlet basin and sediment, right? Okay. How can two sampling points represent the full microbial diversity of fish processing wastewater system?
Okay, so we choose those samples because in general, usually in in processing industry, there are some of the basin that filled with different types of effluents. So the inlet basin is like the first effluent that came out from the processing industry itself, and the sediment samples is the one that were already processed. So why we choose those samples? Because we try to compare. Is there any different in terms of microbial community and such? But in this research study, we focus on the bacteria strain, mostly on the inlet basin samples, and their ability to produce proteolytic and lipolytic activity, because the substrate that came from the fish processing industry itself, the first one that came in the inlet basin, still contained a lot of the protein and lipid, but the one in the sediment we took from the end of the basin, so they have different structure and different nutrient that.
Okay, thank you. Second variation, this is for single fish wastewater. So, do you consider, you aware that annotated for by homolog with unvalidated function and unknown industrial relevance? I mean, from one fish wastewater, this is a bias. You can see it's like you claim of profiling and bioperspective of both internal and external is valid, but just from first, I mean, from the one single fish water, do you think there is another variation from another fish water? What do you think about that?
So in here, it's a little bit different if you see from the statistical perspective. But in this case, as I mentioned, this is the expanded exploratory study. So as long as there is a lipid, the fat, and the protein, we can get the bacteria that produce the enzyme protease and lipase. So it doesn't matter if it's meat processing or chicken processing, as long as it has lipid or protein, we will still get the same result.
Yeah, thank you. But from the research, we can see there's a bias if you just got from one source. You know, if you can one source, that's a bias. I mean, there is a variation for another source. What do you think about
Yeah,
that?
I understand. I didn't claim in here. We didn't claim that we only can get this kind of bacteria from that particular industry. We say that in that particular industry, the fish processing industry, we can get the bacteria like this. But nowhere in our presentation that say that's the only place to get the bacteria with the
Yeah.
enzyme activity. So that's not bias in our opinion.
That's true. I think you can also extend your research with more fish water place. Yeah, I think that's for me that you can. This is a good, yeah, the root research promising. But if you just only make one fish water, I think that is very low and very shallow. Yeah, thank you.
Yeah. Okay. Yeah. Let's see about that because yeah, we can. Yeah, that's a good suggestion. Actually, it will be more. How can I say? What is the opposite of shallow? Thick. Deep. Yeah, the result will be deeper if will be deeper if we include more industry. Yeah, I agree with that. Thank you for the suggestion.
Maybe also for the suggestion, we could use that in another industry from different cities, so we can kind of make a comparative study in their microbial community. So that's a very good suggestion. Thank you, Pak Moses.
That's all. Time's up. Thanks for the one on this 80. So the winner for
for this match is team. Congratulations for team. Okay, before you go, we have some feedback from.
Okay, thank you very much for the discussions. Uh, you each of the group you have a very different topic ya. Yang ini humor, yang ini apa tadi? Okay. So for the first round, some questions is about the objectivity of the tools. Yeah, you questions the objectivity of the assessment because to you humor is very subjective. Gitu. How can you quantify humor? That's the questions. Yeah. What I understand from your group, actually you have used the valid tools to assess humor. So because of that, you can address the concern very easy actually. Yeah, just say that, okay, this is the tools that we use, humor scale, and the scale covers, for example, I don't know, 3 domains. So it shows humor from 3 aspects, for example. So that kind of explanations will help you to show to the opponent that the way you assess humor is valid, especially if the tools are widely used and validated, including for Indonesian subjects. Another question, you also questions the objectivity of the conclusions, because when you see the scatter plots, it seems that the data is very scattered. So you cannot see any pola, any pattern. So while the conclusion seems that there is an association between the humor sama distress. So again, for this kind of concern, I think your group can response by showing the objective measurement. For example, yeah, if it is correlations, then the R, the P. If it is regression, then it should be the OR and numbers. Yeah, so because you did the analysis, statistical analysis, so statistic can help you to justify the objectivity of the conclusions. Yeah, maybe the scatter plots look scattered, but the P, the R, and the OR, for example, says so. So then you are confident with the conclusions. For the in the second round, there is also they also questions you whether or not the way you collect the samples, which is only from one side, is overclaim gitu ya, for the conclusions. And you convince us that you don't have any attempt to do generalizations. Yeah, you only claim what you do. I mean, you take the sample from this side and that become the title and also the conclusions. Yeah, as long as you don't overclaim. So I think you good. I mean, the conclusion is still okay. Thank you.
Yeah, I think it's the same as a previous group there as well, right? Then when they claim about some finding and it applied in that kind of area or specific type of area, so I think that's a good to defend as well to your research. Yeah, so I like the discussion or the debate when it started with asking about foundations when you did this group did and also the other group did. But on top of my mind now that the group D18 the 80 when asked about the finding, you lay out all the numbers about sample size, p-values, and everything, which is good. But the fact that we only have 30 seconds, I don't think is a good strategy. So maybe you can summarize it with a more concise statistical research, but not layouting all the details about samples, p-values and everything, but maybe it's just specific about maybe OR or whatever measures the main point of the measurements. So I think that's in my note. So yeah.
Yeah, great job for the two teams. For me, I think we learned about communicating effectively because you only have 30 seconds. And Moses, you asked about the validity of the study, but you put so much word that maybe the opponent is confused and they said like it's so flowery that he mentioned. So I think like the thing that we can learn is you only have 30 seconds, both of the teams. how do you attack effectively asking direct question, because you need to think about the next step after they answer, like what is the next step of what you gonna ask. And also I think I'm just curious about how do you difference between the stress and distress, because I think the team 51 asks you about what is the difference, yeah, between stress and distress. I think you understand the methods really well, but maybe please communicate to us what's the different, yeah, about the stress and distress. Yeah. And for team 51, I think you got attacked by the because of the small. You only have one sample, like one homogen sample. So I think it's you should prepare for the next competition about how do you answer those in a different kind of way. Yeah. So yeah. Thank you. If you have any answer for us or like your concern also, yeah, please.
Thank you for giving us suggestion and
Yeah.
comments or
Yeah.
judges. Yeah, this is a good input for us to uh, improve our argument or our debate skills. But on those flowering words, it seems that it's evaluate the, I mean, the level of language of some.
Oh,
If you
okay.
know the language, so flowering is not flowering. You just know the objective. Because I know Pak Gary from exact from the biology.
Oh.
I can how can I say, I can serve your flowery language, but this is competition. 30 seconds, as the judge say. We have we need to do the different style. I think I agree with the judge.
But we appreciate the difference Bhinneka Tunggal Ika but for the serve of just communicating effectively, because like it's for, yeah, for us to assess, oh, you can answer it, or but yeah, just take it as a grain of salt, like, yeah. Thank you.
Okay, thank you for team 51 and team 80. Okay, before we go to the next match, I think we can get rest first because we're just waiting for another match to their result before we begin this match. Maybe we can take rest 5 till 10 minutes. Okay. Yeah.
Oh gitu. Jadi setelah menjalani selama ini.
Okay, we can start the next match. Oh, ke toilet. Okay, just wait for that. Please prepare for team 26 and team 36. First team 26. Okay, and 36. Okay. Just waiting for the operator and we're gonna start shortly. Okay, may I invite for team 26 on left and team 36 on my right. Okay? Get your seat, please. Now we can start for match 16. 36 here. Okay. And team 26 here. Okay. Yeah. Langsung main lagi. Okay, who will be the first? By agreement or you want to switch? Okay, so based on agreement, team 26 will go first. Will go first with their idea. So please prepare for their presentation. Yes, you just say next, and operator will next your PPT. Okay. Team 26, the left one. Okay. Please set the 3-minute slide first and set the 3-minute for the timer. Okay, we will waiting for operator. Okay, for the first round, are you ready? Pak? Okay, just keep calm. Okay, you can start your presentation now.
Okay, our study is about the phylogenetic group distributions and virulent gene profiles of clinical Escherichia coli from West Kalimantan. Next. As we know that the antimicrobial resistance is the most urgent public health threats. 1.27 million deaths attributed to AMR globally in 2019 and 97,000 deaths in Southeast Asia alone. And Escherichia coli is one part of the crisis that from previous study show that the resistance up to ceforaxin reach 85% in some settings, and also they have some virulent genes, further enhance pathogenic potentials. Our challenge is Escherichia coli strains are increasingly difficult to treat, and their virulence and resistance profile are shaped by their phylogenetic background. Yet in Indonesia, also in West Kalimantan, there is no local molecular data. To fill the gap, we aim to characterizing the phylogenetic distribution, virulent gene profiles, and antimicrobial resistant patterns of clinical E. coli isolates in West Kalimantan. Next. Our study conducted in Dr. Sudarso General Hospital from June to December 2025, and we used several specimens for identifications and susceptibility testing. We used BD Poinix. For extractions, we use Prestomini DNA bacterial kit. For confirmations, ESBL gene detection, phylogenetic grouping, and virulence gene profiling, we use RT-PCR methods. Next. From our study, show that the 100 resistant to ampicillin, cefazolin, cefotaxime, and also high resistant to ciprofloxacin and cotrimoxazole. And from this study show that only carbapenem groups susceptible to our isolates. Next. From molecularly, CTXM was the dominant ESBL gene across all 4 value groups in these populations. One group A isolate uniquely carried all 4 ESBL genes simultaneously. Next. And for virulent gene profiling across phylogenetic groups, the study showed the phylogroup group B2 and D show the most virulent gene found in this population. And conclusions. Next. The carbapenem remains highly effective, though emerging resistance is concerning. GTXM as the dominant ESBL gene across all phylogroups. And phylogroups B2 and D harbor the more virulent genes detected than other phylogroups. This finding highly the need for antimicrobial stewardships and molecular surveillance to control this spread. Thank you.
Okay, thank you for team 26. And please set the timer for debate session for 6 minutes. Okay.
Check. Okay.
Okay. Are you ready? Yes. Okay. Debate session can start now.
Okay, thank you for the great presentation. About our initial question is why you choose the E. coli for your research. As my limited knowledge that there's other bacteria that relate to AMR2. Why you choose the E. coli one?
Thank you for the questions. So, actually, we are not only doing the research only for the E. coli. We also did have did the for Klebsiella and Staphylococcus aureus. And for the third term, we use Escherichia coli because the concern is also this isolate is the third most isolates that we can collect from the Dr. Sudarso General Hospital. The third.
Also, it's remind the most bacteria that you collect from the hospital like that.
Yes.
Yeah, okay.
The third highest.
Okay. It's you chose E. coli because the population that you choose um, give the E. coli in highest for the bacteria, right? This is like
Yeah,
that.
yeah.
Okay.
The third highest.
Okay, then our next question maybe it's also general. Why the West Kalimantan itself? Because E. coli is also E. coli resistant. E. coli resistant is also a problem in of all the
Okay, I get it. We know that EMR not is a problem for only one province, but also national or global. But there is no molecular data or resistant data from West Kalimantan that we know West Kalimantan also, besides the Malaysia, so we have a borderland. So it is crucial we have need this data to uh, to mapping the resistant pattern from this province.
Okay, thank you. And then for the regimen that you study about the result is meropenem, like is the most effectively for the is meropenem is the regimen for E. coli itself.
Uh,
Okay, so the antibiotic that we do in the study is specific for E. coli. Yes, so meropenem and imipenem is suitable for E. coli.
Oh, okay. So that I will continue for the question about the resistance 100% in ampicillin, like that you saw before. So as your suggest that we have to delete or remove this antibiotic for treat the patient with E. coli bacteria or not, or what your suggest for your finding in the clinical, like specific in the clinical treatment.
Yes, it is one of our goal of study because with the data, so the clinician can choose what the specific antibiotic that they can use for patient, especially with E. coli infection. So the clinician, of course, the result for every patient is variable, different each other. So if the ampicillin is resistant for the patient, so the clinician will not choose the ampicillin, but will choose the susceptible antibiotic.
Okay, it's for the outcome of your study, but how to make those outcome implement for the regimen of infection of E. coli.
Okay, our study, the data, it will plot as antibiogram in the hospital. So with this antibiogram, the clinician can choose what is the best antibiotic for their patient, especially for E. coli infection. And then the hospital can make program for the infection prevention control based on the antibiogram also. And then maybe globally for the bigger data,
the antibiogram also have play a role in One Health, a antimicrobial resistance program.
Okay, thank you. And so you have a value range for the resistant, like, oh, we choose that antibiotic because they have a less than 50% resistant for the bacteria, like that, or
Yes, yes. What
what
we show in the
Mhm.
presentation is one of the antibiogram.
antibiogram, and what
Yes.
the range of the value for the choose? Oh, this is the best antibiotic that we can choose for treatment the patient.
Okay, from our result also show that we categorize the data from 0 to 49% susceptible. We use red, and the yellow ones is 50 to 74, and the green one is 75 to 100%. Also, this is the to the clinician to use the susceptible one, the green one, or the first one.
Okay, thank you. And I will back to the method that I have time. So you have a specimen, a lot of specimen from the feces, urine, that you generate all, or you spare it for those specimen.
Okay. Okay. So we are doing the same things to all the specimens. So we are isolate the bacterial, and we isolate the bacteria, and we follow the identification, susceptibility testing, and also the etc. So we are not making the grouping. Yeah.
Okay, time's up. Okay, thank you for team 26 and 36. So now your score you can see on the screen. For team 26 is 14 and for team 36 is 9. Okay, so now we're gonna move to the next round. For the next round, you will be the presenter. Are you ready? Okay,
Check ready.
for team 36, you can start now.
Okay, our study is about cost effectiveness of multi-target stool DNA-based screening for high-risk colorectal cancer population in Indonesia, a Markov models analysis. So, guys, do you ever think that how if we not do screening for cancer? Next. Screening is really important because it reduces 50% of mortality for CRC patient itself, but contrast with the benefit. Next. The compliance rate decreased over decade. It's because the modality of the test FIT has lower sensitivity, which increase the colonoscopy demand, with no one like to do that. So there's alternative that stool then a test that have a higher sensitivity like FIT, but it's not invasive. But it's more expensive than the FIT. It's beneficial for Indonesia as a lower middle income country. So our study next want to address to compare the cost effectiveness of FIT, Colotech, and no screening among high-risk CRC population in Indonesia. Next. Our study used Markov model simulation with that want to analyze the progression of the disease over 100,000 population with the intervention use Colotech as multi-target DNA stool base, and the population itself is starting age with 45 until 85 years old. With the comparators itself is FIT that use annually and without screening. The observation will be compare the ISR value. For the uncertainty analysis, we use one-way sensitivity analysis and also the PSA analysis. For the strategies to evaluate the different screening interval, we use a scenario analysis with 5 scenario analysis that you can see in the present.
Okay, I will continue for the result that we can see for the result in the base case analysis that yield ISO value in 91.2 USD per quali. This is deemed cost effective because this value is under the willingness to pay threshold in Indonesia. And for the scenario analysis, that the best scenario is the scenario 5 yield the lowest value of ISO. Next. And this is for the uncertainty analysis that we conduct the deterministic sensitivity analysis. Both of them is same like the parameter that make ISO value has the weight range is the discount rate of utility and discount rate of cost, and also the Colotech pricing. Next. And this is for PSAL probability sensitivity analysis that we conduct for the comparator one that has a 100% probability, and for the comparator non-screening has the 99% probability being cost effective. Next, this is for the conclusion being the cost effective. And yeah, thank you.
Okay, thank you for presentation from team 36. So now we're gonna start the session debate. We set the timer for 6 minutes. Are you ready? Okay. Okay, you can start now.
Okay, thank you. Okay, from the method if I'm not mistaken, you do not use colonoscopy to be a comparative to your study. Why you out the colonoscopy to be comparator with which is that we know that colonoscopy is the gold standards.
Okay, thank you. Because we searching in the literature that we use the colonoscopy as a follow up for the screening. That for the first time, the patient is get the stool test like FIT or the Colotech, and then if the result is positive, they will continue to the colonoscopy. The colonoscopy is the only follow up for the positive result in the blood test. Why? Because the colonoscopy is because invasive screening that make the participant rate is very low for doing the colonoscopy. So for the first time, is using the blood test.
I wanna adding for, as we mentioned, our title is for early screening, that we compare FIT as the early screening as the suggest for Permenkes, and then we want to have give alternative for this early screening, because the FIT itself is less sensitivity, which is give
Continue the questions. Why you use Colotech and MIT fit FIT? That we know that
Okay. So choose the Colotech and FIT. It is the same method, stool data base.
it's different.
Different.
For FIT itself, it's detect the blood from the feces, from the stool, that can maybe appear when the patient come with the late stage of cancer. But for the FIT, for the Colotech, it detect the tumor DNA that that sheet to the stool patient, which is it can happen in early stage of CRC patient, so it's more sensitive to analyze the CRC.
how about the sensitivity? Why you choose the two of them? Beside that, we know if the patient also have to doing the colonoscopy after the result is positive. So how about the cost effective?
For the sensitivity, as we mentioned, that FIT have a lower sensitivity rather than Colotech. From the journal that we search, the FIT, the highest sensitivity, it account approximately 80%, but for the Colotech, it's about 92%, which is the highest sensitivity. The highest sensitivity will conduct a highest result of true positive, which is when the patient really have CRC, need to colonoscopy, they will not get the false positive. So the patient will not do colonoscopy in useless. So yeah, because it also invasive.
Okay. Maybe how applicable are these findings to rural Indonesians population with the limited healthcare infrastructure?
For the application itself, right now the Colotech is still was available with the private sector. So we use Colotech to alternative in FIT that suggests from Kemenkes. But for the more applicable in the future, we want to conduct more cost effectiveness study first with the real life data of the national demographic, so it can be clear that the Colotech itself, beside the high price, it's also have cost effective and give the best quality of life for patients.
And we also want to this Colotech can be included to the BPJS to the patient that we all cover all the population in Indonesia like that.
Okay. You use cost effectiveness study. Was budget impact analysis performed alongside this analysis?
Okay, for the budget on impact analysis that we not analyze right now because this is the initial research that we see the how to cost effective this being. But when it be cost effective, we like you said before, we have to conduct the budget impact analysis. But from the previous study that not in Indonesia, the budget impact analysis for the Coltech is also make sense for the being cost effective after 5 years implementation like that.
Yes, of course. Based on our study, the cost effectiveness show that Colotech can become applicable for Indonesian to early screening CRC patient. The ISR value that we do is give the
So the final score, congratulations for team 36 with score 24. Okay, maybe before we go to the next match, we have to from Agus. Yes, maybe 5 minutes for 3 judges we allocate. Okay, so
Okay, I enjoy so much the debate, yeah, because the questions are clear, the response are also very clear, so that's good, yeah, for both of the team. But I still see that there are some moment that actually the opponent can attack more. For example, when you ask why E. coli and you say this is the third highest, you can question why not the first or the second, ya. Kan masih ada dua lagi di atasnya, ya. So you can attack more. And also when you ask why West Kalimantan, and your answer is because West Kalimantan doesn't have the database molecular. So you say, I think that's also the case for other provinces, gitu ya. So what make West Kalimantan special? And you say it's something to do with being located in the boundary with the Malaysia, but you can ask further, gitu. What do you mean by, I mean, being in the boundary? What is the effect tentang resistance? Is there any effect? So if yes, so should we do that for all the, because Indonesia have many area boundaries with other countries. So you can attack further. Yeah, thank you.
Or maybe one thing that I want to highlight about positioning your research, like if they ask like they question your screening and diagnostic yang you push through about the sensitivity and specificity, and you answer about because you position your it's a early screening assessment, right? So maybe highlight like why is it not I think you asked a great question, like why you don't compare to colonoscopy. Colonoscopy is the gold standard, and I think you should highlight like, okay, early screening. You can also do early screening for colonoscopy, actually, right? Yeah, because like as a clinician, we were taught that colonoscopy can be used as long as the patient wants it, but because of the difficulties of you have to do the pre-treatment of colonoscopy and stuff, I think like you should highlight like why is it not being done as a early early screening. But you asked a great question, and you also asked a great you both are a great team, so yeah.
Yeah, just want to add, just appreciate all the effort because I saw that you both are tired, but the endurance are still strong there. So I really appreciate it. Yeah, and as Bu Ade mentioned, that I really enjoyed the discussion as well because like we keep the questions back and forth, back and forth. So I enjoyed it. Despite of you look tired and then you, but yeah, appreciate it. Yeah. Sudah Kak.
Okay. That's all. Okay, thank you again for team 26 and team 36. You can go back to your seat and let's move to the next match. Please prepare for team D0017 versus team D0035. Are you here? Okay, let's check it first. Where's team 17? List yang mana, Bu? Where is team 17? Are you here? How about team 35? Team 35 or 17? 35. Okay, just please get your seat. And for team Okay. Okay. Just take a deep breath first. Okay, without any further ado, are you ready for team 17 and team 35? Who will be the first? Are you want to switch first? Yang kalah mau apa? Jadi pertama atau yang kedua? Okay, so please prepare for team 35 will go first. For operator, please set the PPT for team 35 and set the timer for 3 minutes. It is yours. Yes? Okay, are you ready? Okay, for team 35, you can start now.
Okay, we are from team D35 and our research is determination of genetic markers associated with WD rice using generalized linear mixed model in a genome-wide association study. Okay, so rice is a major staple crop consumed by more than 3.5 billion people. This is highly important for global food security. And through the domestication, rice has developed important traits such as the seed coat color, which distinguish by cultivated white rice and weedy red rice. This trait is influenced by the genetic variation, and it can be studied by the GWAS. Therefore, the conventional GWAS approach, such as linear model and linear mixed model, has some assumption like independency and normality, which may not be suitable for the categorical data. In this case, is seed coat color. So in this study, we use the GLMM model for a better accommodate categorical phenotype data.
In this study, we conduct GWAS using GLMM or generalized linear mixed model, and we use genotype and phenotype data from Oriza sativa indica. The genotype data were obtained from 3,000 rice genome project, consisting of approximately 404,000 SNPs, while for the phenotype data, we use seed code color classified as red and white. After quality control and filtering using call rate and minor allele frequency, a total of 864 Oriza sativa indica accession were retained for our analysis, and and to account for co-founding effect, the population structure was controlled using PCA, and the genetic relatedness was modeled using genomic relationship matrix using or GRM. As we can see from the figure below, we indicate a strong association signal from chromosome number 7, and this finding further supported by the LD heat map or linkage disequilibrium, which shows that. Okay, thank you for team 35. Okay, now we're gonna move to the next session or debate session. Please set the timer for 6 minutes. Okay, are you ready?
Yes.
Okay.
Kamu dulu.
You can start for debate session now.
Okay, I would like to ask about the discovery. What is your discovery in this research?
So the discovery from our research is the SNPs that associate with the seed coat color from rice. That we know that the chromosome number 7 is significant SNPs that control the seed coat color.
So what will be your critical implication from this study? Implication. Useful implication. Useful implication for this study.
I think for the useful implication, for for the farmers that want to because weedy rice is very uh, can decrease the rice producing from the farmers. So maybe from the SNPs we can control the proportion of weedy rice, so we can increase the production for the rice.
Okay, it is like for the breeding or the weed management. Is it breed and weed management?
Yes,
Is it
yes.
like that?
Yeah.
Okay, so what's your? I would like to ask about the marker in chromosome 7. It shows pigment like red or white. So what is the novelty of chromosome 7? What is used for the chromosome 7 actually?
So the chromosome number 7 is we know from our research and the further findings that the chromosome number 7 is from the yeah, from the previous study, we know that the chromosome number 7 is control the seed coat color. Yeah, like that.
So from the seed coat color, what is your biological reason to choose the seed coat color as the representation of the weedy rice? Or what is your biological reason to choose this chromosome 7 for seed coat color as the feature of a weedy rice? How is it represent the feature?
Okay, so we know that the rice is white, right? Okay, and in the study we want to control the the amount of the weedy rice because it can okay it can decrease the production of the white rice. Okay.
Does the color of the rice represent the feature of a weedy rice? So the color, will it or is it represent the feature of the weedy rice? The color, the chroma from the chroma.
Yes, the weedy rice color is red and the cultivated rice is white. So we want to know what chromosome is associated with the color itself, and then we found that the chromosome is number 7 is associated with the color itself.
Okay, so what's the difference between the white and the red weedy rice? Like, what's the novelty of it? Like, we have known that the chromosome 7 has cells and has cells in some papers. Like, what's the novelty by found that chromosome 7?
Maybe you can repeat your question.
Okay, so what's the novelty from found the chromosome 7 in your research like that?
I think for the finding of chromosome number 7 that associate with seed coat color, it will help the farmer to produce more uh, cultivated rice than weedy rice.
Time's up. Okay, thank you for team 17 and team 35. So we're gonna go to the next round. For the next round, you will be the present.
Okay.
Just prepare for team 17.
Okay.
Are you ready?
Yes.
Okay, you can start now.
Okay, this is our presentations about the subtype specific SIA space signature as therapeutic caps in epithelial ovarian cancer. Here's the presentation. Next. Okay, ovarian cancer, the silent killer, the epithelial ovarian cancer, mostly the epithelial, and among postmenopausal women. So, is it correlated or not for the aging? Let me know. Okay, there's a subtype of ovarian cancer like HGAC, CCC, MC, and AC. Next. Okay. Oh, okay. This is the senescent cells. The senescent cells produce the SASP, which means it contains any chemokines, inflammation, or etc. So it can attract and modify the microenvironment. So it would be better or bad for the cancer. Okay, this is the SASP, and this is the methods of. I would like to highlight the inclusions. The inclusions we include only the stage 3, and also we input the proteomics database. And next. Okay,
This is the flow where we process the data, normalize it, and finally we use visualization for the differential expression. And this is for the PCI result. It shows that there's no significant different patterns between older and younger group, like they're overlapping each other. This is also found in the MCA, that this is the older and the younger. The older shows larger, which means that it's more diverse in proteomic secretion. And then this is for the volcano map. It shows that it has no significant upregulation or downregulation of the SAS signatures, but instead we still have this significant result of proteomic secretion in each different subtypes, and that is also correlate with the aging. This is the heat map. We can see at the glimpse it looks diverse, but we can see from this the young group, and this is the older group of the AGSC. For example, we can see that this pattern is red, which is upregulated, and this one is blue, which is not as strong as the red one, and is also in the different subtypes. And this shows a proteomic profile for each group and subtypes. So the conclusion is there's a unique pattern of other protein-related SAS that is discovered. And this is potent for the therapeutical gap, because the unique pattern itself will shows that which part of the personalized medicine for each of from the different subtypes, in whether the older or the younger group.
Okay, time's up. Thank you for Team 17 for your presentation. Let's set the timer for 6 minutes for the debate session. Okay, are you ready? Okay, you can start now. So consider the limited and heterogeneous data. How generalizable are your findings?
The generalization.
Yes.
Oh. Okay, so actually it's diverged, but it has these distinct profiles between the subtypes. It has four subtypes, and in younger compared to the older group. And it has distinct patterns, which is it could be used for this personalized medicine, because each of it has different protein subtypes that it can be used for probably like senolytics, drugs, or anti-senescence, immunotherapy, and something that will blocks the inflammatory state or the protein that is upregulated in certain group.
Okay, the next question is I see that your sample size, especially the proteomics, is 244, I think. Yes. Yeah. I think it's relatively limited or no? Yeah.
Yes, because we actually use some literature of the SAS reference signature, so that we can find which SAS related proteins that is upregulated. So this is already filtered, just especially for the SAS itself.
Okay, but how do you ensure that it represents the broader population?
Well, it's actually
There's limitations of the study. I don't want to overclaim the study, but I have 2 points of the study. The first point is about this is not confirmatory study. This is the discovery study. We want to know the profile from the head map or the volcano map and also others. We would like to know which one is profiling these proteins, like the homogenes and the heterogenes between it.
Okay, so your research or finding is still exploratory rather than the clinically actionable. Yeah.
Yes, it's a via discovery.
So if your key results are not statistically significant, how can you ensure that the identified patterns are not just noise?
So actually we classify it in each subtype. So each older and or younger group, and then we just correlate between those two, so we can tell that it's from distinct subtypes, not like from everything. So like it's more we make sure that the noise is produced or not found.
Okay, the next question is about the PCA and MCA. I want to question what variable that you use in PCA and MCA.
Age group, subtypes for different subtypes, and the proteins for the X and Y axis.
In your PCA and MCA, we can see that some separation, right, between the group. Did you do the testing for this separation? Are this is statistically significant or not, or something like that?
Okay, so the PCA and the MCA, it shows between older and younger, it's overlapping. But the older one, it shows more diverse, which means that in older group, it actually upregulate certain proteins that it's related to the aging. So therefore, it shows the larger circle than the younger one, but they are still overlapping. And for the significancy, it's not showing difference or separate patterns. So therefore, it is not significant. But we find certain proteins that is not found in the literature or the reference that we use, but still correlate to the age. Or the, yes.
So it's just visually apparent, right? Or you do the calculation, something like that. Using.
Yes, we use the PCA, MCA, the volcano plot. So first we use the volcano plot for knowing which protein that is significantly upregulated or downregulated by in Lima.
Okay, we use analytically by Lima because that's a proteomic data.
I want to ask, do you use any statistical method to control the bias?
Yes, so since the data is kind of diverse, so we use normalization and also for the number of the samples also limited. So we use this lemma. So because it's limited, it's in smaller size. So yes.
So your sample size differ across the data set, right? And how does it affect the statistical power of your research?
Okay, so we actually compare both each the subtypes and correlate with in per subtypes and different subtypes. So we can have a significant result because we also compare it through the each subtype. So like it's different from if we compare it to the all of the subtypes. Yeah, so we have the significant result because we compare it. Yes.
Time's up. Okay, thank you for team 17 and team 35. So the winner of this match is team 17. Congratulations. Okay. Maaf ya, Kak. Okay. Okay. Please maybe feedback from the chat. Ingin istirahat. Okay, just number. Because
Oh iya ya, jadi ternyata memang teman ya, jadi maaf. Yeah, jadi first maybe I would like to appreciate the team D35 because they were here before, right? You were from another room. Yeah, you saw improvement from the previous debate gitu ya. From the way you clearly present your study, even it is overrun gitu ya. Jadi mungkin for the next time is how to manage your time during the presentation. But I saw improvement there, and also when you were attack gitu ya, when you have to defend your research, you seems again unconfident gitu. Jadi a bit sayang again if I mean when you present you show some level of confidence and then it's dropped. So maybe it's also to improve. Yeah, for the D17, I think there is a good questions or good debate from the other team about using a visualization of PC, yeah, PC1 and PC2, and then from there you claim that there was no there's no overlap gitu ya. So I think that's not a good way to show that there is or there is correlation or there is correlation there. But finally, in the end of the debate, you mentioned about lima gitu. So I think you need to mention about lima first, and then the way you visualize it is by using PC. Because if you just from the start and then until almost in the end of the debate, you just defend your research with PC. I don't think it's a good strategy. So there are also the notes from ini bahasa Indonesia nggak apa kan ya? Okay, I'll try. To D35 when you seems find the weak spot from the D17, but you fail to follow up those questions again. I think there's a big chance for you to take down gitu ya D17 from that kind of debate gitu. One of it is about clinically applicable. You asked about whether this research about discovery are clinically applicable. The team D17 mentioned about clinically applicable, not clinically applicable yet, but then that's it. There is no follow up. So what's your point of asking that gitu? So I think there you fail to to follow up your own questions. So when you ask about clarifying something, you need to prepare. Or if the answer will be A, and then I should follow up this, and if it is B, then I should follow up that one. And also, you mentioned about. I think this is the big. I will say a big mistake when you defend your research when you said that making sure that noise is not found. Wow. So I don't think it's a good it's a bold statement, and there is no research that there is no way noise cannot be found. So and again you fail to follow up on that. I believe you are from more mathematics or statistics. You should pick up that weak point when the other team mentioned about no noise, making sure that no noise is found. I think that's ya agak gatel gitu nggak follow up harusnya di follow up gitu kan ya paling catatan dari saya itu ya monggo Bu sok oh enggak
Yeah. Maybe I just want to highlight that you two have very different research and very different background, and it's hard to understand each other research for sure. But I think you also have this power of understanding. Like you came from statistical background, so you can attack the other person on the statistical methods. Maybe try to increase their critical thinking because you provide better input for them also. So what you ask question your question will help them to improve their research. So see it as your question improving each other. I think that's so don't highlight your power and yeah use it like as a ground as your ground for making a statement. Yeah. So thank you.
Okay. Okay, thank you for judges and give applause for team 17 and team 35. You can go back to your seat. Okay, for the next match, I will invite for team D0048 versus team D0020. Match persahabatan. Okay, for team 48, you can get your seat here. For team 20, okay, you can get your seat here. Okay, who will go first? Okay, by agreement, you want to go first? Okay, please prepare for the PPT for team 48. 48. 48, the left one. Okay, just waiting for the operator. Team 48. Okay, are you ready, team 48?
Oh yeah.
Okay, you can start now.
Okay. Hi, everyone. I'm going to present our research about developing biomarker for early cervical cancer screening. Next, we know that this disease still become a big health problem in the world, and recent screening methods still work well, but they are very invasive and not easy for everyone to access it. So that's why our long-term goals for this research is to develop a simple blood-based test, a biomarker, to give an early screening for cervical cancer. And one of the promising solution is using microRNA. These tiny RNA molecules have an important roles in the gene regulations and also cancer mechanisms as well. Next. And for this study, we use a nanostring to profile microRNA, and we use 12 tissue samples consisting with normal and cancer. Next, and from nanostring data, we profile 800 over 800 microRNA, and we discovered 62 upregulated microRNA and 21 downregulated microRNA. And from this heat map, we can clearly see the distinct microRNA between normal and cancer. And from the volcano plot, we can determine the most prominent biomarker among those upregulated and downregulated microRNA. There are microRNA 1, 2, 4, 6 as an oncogenic microRNA, and also microRNA 542, 5P as a tumor suppressive microRNA. Next. And for further understanding about how this microRNA can regulate the genes in the pathway of cancer, and then we continued this study to use a gene targeted analysis, and the suggestions of this research is those microRNA is involved in the formation pathway of the cancers, and both microRNA have a opposite mechanisms like on off switch. So this is a good chance to develop this biomarker for non-invasive biomarker, and our future work is to validate this finding in a larger cohort. Thank you.
Okay, for team 20, you can start now.
For your research, why are you using FFPE, which is the block paraffin? And it's known that during the pre-analytical process, the DNA, also the molecular, will be degraded, and it will be impacted into your data reliability. Because we know we have no regulation for the duration of the formalin. Why you not using fresh tissues?
So we have paraffin tissue like already like it's archived in the hospitals, and this microRNA is very stable. It's because it's only very short microRNA. It's only 18 to 20 base pairs. It's very stable, so either it's like paraffin and it's in the blood or other samples.
For your result, we know that you assume that the microRNA is really stable, that you can doing the analysis, while also the others like DNA will be fragmented into short fragment like a microRNA. It will lead to like a bias measurement during your research. So why you like to, what is your validation? How you validate this research?
It's back again to our purpose of this research is to know what type of microRNA that we can use as a biomarkers, and microRNA is a molecule that can involve the gene regulations, and specific microRNA can make a change the genes, and this is really good to use as a biomarkers, and I think it's not really uh, apa relevant with the yeah other genes.
Okay. Okay. So we know that microRNA are most likely to express in the localized tumor, rather than if you want to propose it like from the blood sample, which is like it will be much different samples between them. So yeah, if you want to also look for the blood, it will be impacted with a different result. So why you still using at the first the FFPE itself? Why you don't still blood?
Yeah, so we look at some literatures and we found this microRNA that upregulated, the most upregulated, it's also found in the blood. So regardless the samples, we found like what we found is like confirmed. It's already there too.
Okay. Regarding your inclusion criteria related FPE, I'm not clearly look at the inclusion criteria regarding the durations of the achieving FFPE. While we know that wait, yes, it's stable, but you are not like adjusted the durations because it might be real increase the bias or something.
Yeah. So for nanostring, it's very strict regulation in some of samples. So we just exclude the one that is not it's not good, because for microRNA nanostring, you have certain tests like you saying like nanodrop or something like that. It's like related. We have to test before doing nanostrings to meet the criteria.
May we know what microRNA are, especially we know that oncogene microRNA will get attached to tumor suppression gene, and tumor suppressor gene microRNA will attach to oncogene. Is that right? Yeah. Okay. Does we know what kind of gene that attach to your microRNA, and can those gene become further validation?
Yeah. So you asking whether which gene regulate this microRNA expression? That's correct, right? So this genes has been regulated by P53 genes. So it's like you said, yeah.
You said that the stem expressed in tissues and blood. So why at the first you are not using blood?
Because we have these archive samples. If we purpose this sample, that's gonna be our next cohort study in the future. Like confirm these two biomarkers, the one that most upregulated and downregulated will be valid as biomarkers.
And I will add something. Why we choose FFPE, because yeah, it's a large sample in hospital, and by using FFPE, we can validate with a retrospective samples with a larger cohort, and that's very easy to validate with a lot of more samples before we validate in blood also.
Okay, you take the cervical cancers, but your goals is for the pre-cervical cancer. Or we know that there might be like different gene expressions. Why you are not taking the pre-cervical instead?
No, this is for early stage cancer
Oh, yeah, early stage.
biomarkers. So we use like stage 1 and stage 2, not like including the precancerous.
Okay.
Yeah.
Yeah, we exclude the higher stadium, stadium 3 and 4, just to make sure that our biomarker that's only for the earlier stage.
Okay.
Okay, time's up. Okay, for now the score for team 48 10 and 5 for team 11 for team 48 and 6 for team 20. Okay, you wanna start your? Okay, you can start from now. Okay, good evening. Good evening. This is our study. Next. Okay, next. Okay. Cervical cancer remain leading threat to women health despite being preventable. Screening current screening strategy, especially HPV DNA, often
underdiagnosed or overdiagnosed. So we need to improving those diagnostic. World Health Organization has pointed out that the next generation to strategy to screening DNA methylation, screening pre-cervical cancer is DNA methylation. Why using DNA methylation? Because DNA methylation can explain underlying biological change. So hopefully it over the can distinguish which HPV positive woman who undergo this pre-cervical cancer stage, especially cervical dysplasia. So we aim to know what kind of methylation signature in this cervical dysplasia. Next. So we use integrate. So we use dataset from Geo database. We get 4 dataset and we analyze pre-processing in our studio. After that, we doing some statistical analysis and finally we do some gene ontology to know what kind of pathway that come from those list of genes. Next. So from the initial probes, we get hundred of thousand probes, but after we do some filtering, annotation, and also statistical analysis, we got 1,000 genes. And after that, we analyze differently methylated genes. And finally, after gene ontology, we get 2 hypomethylated oncogenes and 2 hypermethylated tumor suppressor genes. Next. Okay, in conclusion, our approach can identification methylation signature for cervical dysplasia can help women to know, especially women with HR-HPV positive, to know what kind of stage that they are going process. Hypermethylated tumor suppressor genes in DNMT1 and WT1, hypomethylated oncogenes in CSV1 and BCL2L1. And for this research, we also get the global biomarker, so it can hopefully it can use in other ethnicity. Okay.
Okay, you can start from the minute. I'll set my timer first. Okay, you can start from yes.
Oh yeah, thank you. You have a good research. I have a question. In your poster, you did a systematic review or something, and you mentioned you use data up to June 2025, and there is no information about the minimum year you use of your data. And can you explain the period time of your data?
Okay. Actually, the June 2025 in our poster is indicate the time we searching, include and filtering database. So we search what kind of data set that reliable and with this research, such as had a HR happy HPV positive woman using the same microarray, and then yeah.
Yeah. The next question is how can in your thought, how can discover methylation biomarker can be translated into clinical tools for early detection for cervical instead of we have a pap smear now and then why we use methylation?
As we know, after HPV infection, what those virus do is replicated themselves. They replicated themselves while hijacking those normal cell to alteration the transcription factor, which is using by epigenetic factor by methylation. So we hopefully this methylation analysis can be especially quantification, so we can using a risk factor for HRHPV women as predictive their how long they will get those cervical cancer progression.
Related to that, you know that methylation is not fixed. So it can be changed by food,
Yes.
by environment. So how do you know like your mechanism, like you proposing this, but it's gonna be changed a lot.
Oh yeah. In novelty in this study is also the statistical analysis. We're using three statistical analysis: lima linear model, empirical Bayes method, and standardized effect size. So we extensively research, analyze, and statistical analyze what genes that had uh, consistently change in each data set. So we hopefully that will represent what changes in environmental.
Will you consider the risk factor, like the situation of the food, probably like some cancer patient, they are wealthy, they can have like for healthy food, for example. So it's gonna change their hypermethylated or hypomethylated gene. So
Okay. In our that's our limitation. Actually, we didn't know what kind of environmental that will interpret the methylation.
It is because it's from the data set, and it's yeah, it's we receive the secondary data, so that's might be the our limitations. But in the further research, we that you validation, we consider the variable itself.
Okay, a question from me. And then as you said that from your your research, you will validate the data use within the patients, and which kind of samples that you will use for validating the data maybe.
Our ongoing research in under this title, we sampling HR-HPV positive women, and we also analyze their risk factors such as
Yeah, we probably can using swab, so the person, a woman can do it by themselves. So so it might be not harmful and not invasive. This is our goal to make it woman safety.
so how you gonna test that? Which method you're gonna use and why?
Oh yeah, we use Oxford Nanopore technologies because it had a long reach. So hopefully, when we analyze that, there is no fragmented or wrong read database. So we only use ONT for now.
So in your poster, you mentioned these 4 genes related to immune modulation, dysregulated gene, and other things related to cancer. Can you explain a little bit more why this is like related to immune modulation and what is the effect?
Oh yeah. These genes can change immune modulation, especially the CSV1, because CSV1 it can change because if methylated happen in CSV1, it can change the macrophage. Macrophage will be more anti-apoptosis or anti inflammation, so it will be more. Yeah. Time's up. Okay, thank you. Okay, we have extra time for 4 minutes, 2 minutes for you as a defender team, and you will attack them.
Okay, the rule is same: 30 seconds to attack them and 1 minute to answer their attack. Okay, and for operator will setting 2 minutes again for you as a team defender, and you will give your attack for them. And the rule is same: 30 seconds for you to attack them, and 1 minute to you to give them your defend your idea. Okay. Please set the timer for 2 minutes first, operator. Okay, take a deep breath. Just slowly. Aku yang ketegang nih. Okay, for 2 minutes, you will be team attacker and you will be team defender. And you can start now.
So you said the HPV can change the methylation. So how do you know the mechanism? How?
Okay. As I said, when HPV come to cervical cell, they will replicate themselves by change the methylation DNA. How come they will change methylation DNA from hypomethylation to hypermethylation? So they can using those pathway to replicate themselves.
Oh, so for your research, have you looked at is that like different sample from which they are originated will change the result? For example, probably some sample get like more virus than the others.
Yes. Okay. As for when I'm using when I'm searching database or dataset, first we search what kind of sample that you use. In this search, research we use for kind of sample, self sample, self sample, culture cell, and tissue cells. So how we compromise those different kind of cell, different kind of sample, we come back to statistical analysis. So what the lima linear model we can be
Yeah, it can be impacted. Yeah, it's standardized due to our statistical novelty.
Okay, time's up for 2 minutes first, and we're gonna go to the round for 2 minutes. Okay, set a timer for 2 minutes. For operator, you will be the attacker team, and you will be the defender team. Okay, you can
Okay.
start now.
Okay. As I'll be asking, how can you ensure that those are microRNA, not DNA fragmentation? Do you do some DNA quality check by using gel electrophoresis or something?
Yeah, microRNA is actually a really short nucleotide short nucleotide, only 18 to 22 base pair. And for why we choose nanostring can read a short template. So even I think, and then we also use a nanodrop to check the quality of RNA. So we really sure that the quality is really good.
Yeah, it's like a probe. So it's nanostring is a probe. It's already can over like 800, so can identify over 800 microRNAs. It's a probe. Yeah.
Oh, okay. 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 For the future, would you use the nanostring for analysis or any kind of maybe
So now we already narrow down, right? We have like a top 15 upregulated, top and 15 downregulated. So we can choose like top 5, for example, to start with just qPCR. So yeah.
Yeah, we will validate our biomarker using qPCR, using a larger cohort, a sample or tissue.
Oh, okay. qPCR. How qPCR?
Part 4.
Hope we can collaborate later, Kak.
Ya ampun. Ini saudara. Okay. Very great debate. Okay, so welcome the winner for this match is team 48. Okay.
You know, during the 6 minutes, 6 plus 6 plus additional 4, yeah. So it was 14 minutes altogether. If you may notice that there are a lot of questions addressed to the opponent, and because of that, a lot of answers also. I think it is because the debate ran very effective. Because I mean, each of you, when you answer questions from the opponent, that's really address the questions. Yeah, so you don't go here and there. So because of that, and the questions are also relevant to the study. So make it it's just focus. I mean the debate focus on study each of you, and the clarity is good. The clarity is good. And when you ask, for example, when you try to clarify something, yeah, I don't know your name. I mean, you ask why you choose this approach. You don't just ask. I mean, you also add that with you have your own opinions. I think this kind of approach will work too. But why do you choose this? So when he questions, he doesn't come blank. I mean, he has an idea in his mind and he questions you. So that's a good way ya. So you don't just cek ombak mau dijawab apa nih pertanyaan gue gitu ya. So you really have something in your mind and you answer whether it is also considered relevant by the opponent ya. And the other things that is also good is the way you project questions and answers, that's yang very menonjol in this debate ya. You are confident. We then understand that you really into your study. Kelihatan sekali ya, you understand your study, and you also when you address questions to the opponent itu bukan buat bukan buat nyari salah gitu ya, buat it is indicated from each of your questions. So that's really good because that's the debate should be. Yeah. Thank you.
Thank you.
Yeah. Really appreciate the debate. It's so exciting to see you both actually because you both show how knowledgeable you are in the field that you are research for. Maybe one of the I want to highlight about team 48 questioning the methylation and hypomethylation and so but you asked like twice. I think you're really honing into those methylation. maybe explore more because I think the team 60, yeah, team 20, you already explained it well also. So I think like deep dive again into others' perspective. If they already know oh, I know that this opponent already understand this. Like maybe search for other fields that maybe you can put on the feedback. So yeah, great job, both of the team.
Okay, again, give applause for team 48 and team 20. Okay, maybe that's for this session or this match, and we're gonna take a break for that first, just for 15 minutes. Okay, yeah, prayer break. Okay, 15 minutes. Quick. Prepare for the next match. Match 25 for team 41 versus team 51. Are you here? Okay. Get your seat first. 41 and team 51. 41? Can get sit here? Yes, sit here. And 41. 41, where is team 41? 41. Okay. Yes, you can sit first. Just get your seat. Iya, makanya udah jatuh. Okay, maybe we can start. Okay, nanti mungkin bisa mulai. Okay, so we're gonna start. Please for the operator set the PPT. Who will go first? Based on agreement? Again? Okay. So are you team 41? Okay, and team 51. So for team 41, please prepare for the PPT first and set the timer for 3 minutes. Okay. Set the PPT first. This is yours. Okay. Are you ready? Yes, Bismillah. Okay, you can start now.
Okay, thank you. Good afternoon. So this is our study. Next. Antimicrobial resistance is often called a silent pandemic, not because it lacks impact, but because it advanced quietly, outpacing public awareness. And from this, the E. coli is a critical pathogen because even though this is a normal flora in our gut, but it also the one of the most pathogen that can cause very deadly infection. So one of the most important thing is due to the anti beta lactamase enzyme production that could inactivate the beta lactam antibiotics, the most used widely used antibiotics. So, recognizing this, WHO designed ESBL producing E. coli as the global AMR indicators across human, animal, and environment sectors. This is one health perspective. So, and it raised critical question: what is the global landscape of beta-lactamase gene diversity in E. coli across the One Health interface? Next. To answer this question, we conduct the study to describe the diversity and global distribution of beta-lactamase genes in E. coli across temporal and One Health dimension using the NCBI database. Next. So we retrieved the data from the NCBI database on November 25th with the query scientific name E. coli isolates. We use the specific inclusion and exclusion criteria, and then we filter the data and categorize into One Health approach. Next. So based on the temporal data, we can see that Blatam 1 consistently represent the largest share of acquired blood gene events. However, we find two gene that progressively become a larger proportion, which is the BLA-CTXM starting mid 2000 and then BLA-NDM5 after 2010. Okay, next. So based on our data, we find the imbalanced data that most of the genes, most the isolates come from the clinical, from the human, and in which the blood TEM and BLA-CTXM together accounted for all, approximately 70% of all blood genes event. And this is suggesting the sector-specific selective pressure. So next. This is the temporary conclusion. The polarized distribution of blood genes across sectors serve a definitive marker of sector-specific antibiotic selection pressure, and the clinical intervention alone are not sufficient. So we need the One Health surveillance strategy to combat the systemic spread of AMR threats. Thank you.
Okay, thank you for everyone. So let's start the debate session. Set the timer for 6 minutes. Ready, operator? Okay, you can start from. Wait a minute. I will open my timer first. Okay, you can start from now.
Okay, thank you for the very informative presentation. So, my first question is why you stop the collecting the data from 2000?
Okay, because most of the data before 2000 is like little even compared to data after 2000, and then the growth of the generation sequencing is one in the 2000. Yeah, our study just like to collect the data is just from 2000.
So it's most why we take 2000 after 2000 because the technology is exists largely after 2000, but the this isolate itself maybe it could be taken before 2000, but the data submit to the NCBI after 2000.
Okay, my next question is probably you only shows the graph in terms of the percentage in between the genes. As we all know, bioinformatics and the database size is advancing throughout the years. So I'm gonna ask why you only include in terms of the percentage, because if we consider that the size is growing, the amounts of the genes on the database itself could also growing, but not necessarily showed in the percentage. So is there any reason why you didn't input that data?
So this is actually a temporary result. We still trying to do some analysis based on the data that we collect, and we actually also try to differentiate not only due to the percentage, but also the like the precise number for each year. But we still don't show it here because we're still doing the analysis.
So the source of the data is from NCBI, right? Yes, from GenBank. Okay. As far as I know, there are the database NR and also RFSec. In your case, what do you use, and does it affect the validity of the data? Because some of data is not reviewed. Yeah.
Yeah, thank you very much. We use NCBI because NCBI is the largest database repository sequence data in the world. Yeah, they have some like DDBG or NA, AB, but for the validity data, we use like inclusion, inclusion and exclusion. Inclusion we like to they have information for the metadata like a collection year, collection geography, etc., etc., etc.
So it means like you use all like the NR, the largest database, not
Yes.
only the RefSec. Okay. So how about the validity? Because I think not all NR data is reviewed by the NCBI.
The validity because most of the submitter like submit the raw data and the set like a complete data, but from the NCBI itself they have like some tools like IML Finder Plus created by NCBI. They analyzes itself all raw data and complete data, and then show the result like gene result, and then they also have analysis to complete the data. If you submit the data raw data, maybe the next few days, your data is gonna be have like a pasta file. Okay.
Okay, so my next question is from the Sankey diagram, we can see that there are some of the genes that were shared in different sort of samples, but you didn't give any comment or any implication about that. Is there any explanation?
The okay, in the Sankey diagram, some of the good the good result is you know the blood NDM is about carbapenems resistant. The NDM type of the submitter NCBR itself is mostly from the human clinicals. Maybe it can summarize what if the blood NDR5 maybe also most come in from animal and then environmental. This just one sample to show the Sankey diagram.
So in your you divide the sampling is from the environment, human and animal.
Yeah.
Human and animal is self-explanatory. So environmental is too like too wide
Yeah.
category. So what is consist in the environment category?
Okay, thank you. What's the determine this is animal or environment? We use some regex data from the isolation source like domestic animal like cattle, like chicken, etc., etc., etc. And then they have also have some information about host. If the host and the isolation source consistent with the animal domestic animal, they include in the animal. Otherwise, it's not gonna be included in environmental.
So for example, in our case, if you get the E. coli from the wastewater from the fish processing industry, it means from environment. Right?
Yes.
Okay. Another question is this is in the framework of the One Health, right? Then how you apply the finding of this of your study?
Okay, yes, so thank you. So this is not directly we can conclude because it's actually not a surveillance data. This is only a snapshot. So we only see at a single time the distribution about the blah genes. So in this study, we conclude that we need actually a surveillance not only from the human side but also from the environment and animal, because like now it's very limited. Even though the WHO have already introduced the surveillance that also including not only human but also animal and environment. But what happens? Especially like in Indonesia, what we usually do is more about the human, not the animals and the environment.
Okay, thumbs up. Okay, for now, the score for team 41 is 11 and 13 for team 51. Yes. Okay, go to the next round. You will be the presenter. Okay. Are you ready? Okay, you can start now.
Okay, so this is our research. Maybe we can next to the next slide.
Slide.
Okay, so fish processing wastewater is kind of like a gold mine for enzyme with with high enzymatic activity. Imagine it like a cave of wonders that filled with golds and maybe magical stuff. But these environments are enriched with protein and lipid substrate that can be used by the microbial life to thrive, and those microbial could produce some enzymes. And in this case, that we want to do more deeper research. It is the protease and lipase gene. Okay, maybe we can next. So those lipase and protease genes are can be used in both industrial and and biomedical approach. We use double approach in this study, which is a culture-based method and the non-culture-based method. From the culture-based method, we managed to isolate 6 bacterial strains from the fish processing wastewater from Lamongan in Indonesia. Lamongan. All of the isolated bacteria shows potential in both proteolytic and lipolytic assays, but our hero here is the Proteus GB that shows the highest enzyme activity in both proteolytic and lipolytic assay. Further analysis using whole genome sequencing reveals to us its genetic makeup and some of the genes that we supposedly thought produce some of the genes that play a part in the extracellular enzymatic secretion. And in this case, it's a rallysin metalloprotease and phospholipase A1 gene. Okay, next. From the non-culture-based method, we do some 16S metabarcoding. And from those, we could know the community of the bacteria in the samples. We also found that the 6 isolated strains are part of the gamma proteobacteria class. Proteus GB in itself accounted of 0.09% of the total metabarcoding data. So it kind of confirms that the Proteus GB is really present in the samples. Okay, next. So as much as we like our hero to save the day, we can't forget that some hero also have the dark side. And in this case, Proteus GB have the dark side with its opportunistic pathogenic nature. So for future work, will involve designing of recombinant factor for expressions in grass species, so we can safely and sustainably mass producing this enzyme for both industrial and biomedical purpose. I think that's all.
Okay, thank you for the presentation from Shinjitsu. We'll set the timer for 6 minutes first. Operator, ready? Okay. So for team 41 and team 51, you can start the presentation now.
Okay, thank you for the very interesting presentation. So could you please elaborate more about the sampling, the handling of the sample, and the culture procedure? Because how do you choose which isolate which colony for further the WGS?
Okay, for the culture-based method itself, we took the sample from both inlet and the sediments, but in this case, we more focused on the inlet samples because those samples contain more protein and lipids, so we hypothesize that the proteolytic and lipolytic are more commonly found in the inlet samples. So we try to culture those through microbiological culture it, and then we found that we managed to isolate 6 strains of the bacteria, and then we do proteolytic and lipolytic assays to those 6 bacteria. So from those 6 bacteria, Proteus GB shows the highest enzymatic index. So we choose the Proteus GB as our candidate in analysis of WGS.
Okay, thank you. Based my understanding, if you take samples from the environment, maybe there are bunch of bacteria will grow in the culture media. Do you use specific culture media, or maybe how do you manage for the fastidious bacteria that could be also grow from the samples?
Yes, we use the general media, the Luria bertani broth, and assuming that we don't want to grow the fastidious because we need the one that easily grow in the general media. After that, we do the screening, and then that 6 reveal the activity of proteolytic and lipolytic activity. Yes.
Yeah, but on the culture, you only have those 6.
Yes.
Okay, so no others.
It actually grow a lot, but when we identify only 6 species of the bacteria.
Okay, so you choose the most, maybe the similar colony, or
yes, the distinct colony. 6. We found a lot of colony, but 6 actually distinct. 6 type of colony.
Okay.
We took that.
Yeah, so because I believe sometimes it's quite hard to find the specific or distinct colony from the environment, unless maybe you will try to do like a dilution methods to make sure which colony is have the more burden on the samples.
Actually, we did like that
Okay.
until 0. 5, 6, yeah. But yeah, that's what we got.
Okay, so maybe I have one more. So you use both the 16S RNA metabarcoding and culture-based isolation. Could you elaborate more the concordance between those methods? Is there any maybe uh, the same group of the bacteria that it means that we find the same things on both methods?
Actually, the 6 bacteria is from genus Proteus, Citrobacter, and Serratia. Actually, we also the 3 bacteria is from what class? Gamma Proteobacteria, which is one of the dominant class based on the NGS data. Yeah.
So it seems similar.
It's aligned. The non-culture and culture-based method is aligned actually.
Okay, thank you.
Okay, thank you. Your study have used the method 60S metagenomic. Why you use 60S metagenomic? Other like shotgun metagenomics?
Because I think that's the simplest method available in Indonesia, that we can use that to see the community structure of bacteria in some given sample. In our case, is the wastewater. So then we can compare it also with the culture-based method. Yeah, where is the position of the bacteria that we already successfully culture?
Okay.
But also 16S RNA genes are like the conserved gene in the bacteria. So using those 16S gene, we could identify what kind of bacteria that presents in the community.
Because okay, thank you. Have your team consider using shotgun metagenomic, because shotgun metagenomic can detect other protease and lipase gene, because didn't use shotgun metagenomic, maybe you might be miss some other protease and lipase gene, because I think your study is aimed to gene, not the bacteria.
Yeah, that's a good point of view. But in our case, we want the protease and lipase with the proven activity. So that's why we isolate the bacteria, see their activity, and take their gene, because the gene actually work. We see that work. In the case of the shotgun, we got the gene of lipase, many type of lipase and protease, yes, but we don't know the activity. Yeah, that's the reason why in our case we use parallel, the culture-based activity screening, and then the meta barcoding 16 sRNA using the AGS. Yeah.
Okay, thank you. But you can maybe predict the activity, activity from the protease and other substrate, using molecular docking.
Yeah, that's also an interesting point of view. But actually, we are microbiologists. We believe the real data, not the simulation data.
Okay,
Yeah,
okay.
if we have the simulation, I think it's more believable, something like that. Yeah.
Okay.
Molecular docking, we kind of have to find the perfect ligand, but here we kind of did an explorative study. So whatever purpose that we're going to do with the both protease and lipase, we still not specifically choose what we're gonna do with that. So I think using molecular docking would be more useful if we already knew what kinds of usage that we want to do.
Okay, time's up. Okay, the final leader. Congratulations for team 31. Yo.
Can we do sama-sama menang udah?
Oh my god. So, oh my god.
Udahlah.
Equal again ya.
Capek.
Okay, because equal, so we're gonna add 4 minutes. You know the rules for 4 minutes. Adding time. So you will be a team for 2 minutes first. Okay, again, because the score is equal the last time. So we need extra time to get the winner for this match. So we're gonna give you change for 2 minutes for team 41 will be team defender, and you will be a team attacker to attack their idea. And then we'll switch again 2 minutes extra time for you will be team defender, and you will be team attacker and attack their idea. The rules is same: 30 seconds to attack and 1 minute to defend. Okay, it is clear. You will go first, or you will be team attacker? Oh, attacker. Okay, so okay, please start the timer for 2 minutes. First, for team 40, sorry, 51 will be team attacker first. 2 minutes. Okay, are you ready? Yes. Yes, please. You can start.
Okay. So, can you elaborate your future study about the you found the from various ecosystem, and then how can you use that data for the surveillance in the future?
Okay, thank you very much. Again, this is gonna be use surveillance data, but have some interesting future project like SLC actually have second sequence type. Maybe have we use like analysis post MLSD to analyze ST what the isolate is it. Maybe we can some found like maybe some categories have majority about ST like ST1, ST2, ST3, and then we can compare the literature study. This is ST high clone or not.
So actually, I'm the also molecular biology guy. So what I think is you will design some primer to detect the gene from certain ecosystem. Is it right? Is it my thinking right?
So actually, what we were thinking is not like that, because this is not like this is not something that just can jump into a new maybe method that we can invent more and then to detect from the samples. But what we are going to do is to find to show that there is need for the surveillance, the maybe the One Health global surveillance itself. And then we would like to maybe find out the correlation between the strain or maybe the gene that we find in human, and then we compare it to the animal and the environment.
Oh my god! Oh my god!
Udah lah, udah.
Okay.
Kita captive tuh kemauan coba.
Any time for 2 minutes again. You will be team attacker for their ideas. Okay? 2 minutes. You can start now.
Okay, thank you very much. So from the poster, you mentioned that one of your research outcome is to genome mining for protease and lipase encoding genes. Can you elaborate more, because I cannot see maybe the detail on your presentation?
Actually, in that data we show the circular chain, and then we like mark the position of the sum of the lipase and the protease. Actually, we found like more than 10 of protease and the lipase from each from the strain. But in that case, we emphasize the phospholipase A and also the serralicin, because they are extracellular enzyme. The one that actually we see the activity in the agar media. So that's why we chose that two gene.
So you use those genes for further analysis, or?
Yes, we will synthesize those gene, and then we will put it in the plasmid, and then we put the plasmid in the safer microorganism, for example, E. coli PL21D3, and then we will produce the protease and the lipase.
Okay, so you will use for the further synthesis of the protein cell.
Yes, for the synthesis of gene to produce the protease and lipase. Yeah.
Okay, so based on your research, do you find some maybe limitation of your work that you might have to further improve?
Okay, yeah, further improve. Maybe we only get limited gene of the lipase and protease in to 6 species actually. So to further like get more result about the gene, actually we can do the shotgun. But as we said before, we don't do like that because we want to see the real activity. maybe we will use another media, specific media for the lipase and protease producer to get more isolate, and then we can get more gene, maybe with better activity. Yeah.
Hands up, okay. So we get the winner for this match. Okay. So the winner is Team 51. Yes. Maybe just one comments from Bu Ade. Yes, please. Just
Yeah, thank you. Actually, my comment will be very short. Yeah, there were there were so many. I mean, I did enjoy the listening to the debate. Although during the debate there are so many technical terms and also procedures that only you guys know what they are. I try to imagine. Yeah, I try to imagine. But what I'm happy about the debate is like, for example, when you ask your first questions why you collect the data from starting from 2000s, and the answers are actually somehow a bit technical because the apa yang available-nya hanya sejak 2000. Yeah, so this is the reasons are really technical gitu ya. So actually I do expect that you will further questions whether there will be an impact beyond. I mean, whether there is another reasons beyond technical issue, yeah, and because of that, what is the consequences for having such data only starting from 2000? Jadi we miss the data before, and when you say that this is a snapshot, you capture in one time in one period time, and actually they are towards surveillance, but this is not yet the surveillance. So I do expect there will be a questions about what do we need if we want to go towards surveillance. Yeah, starting from this kind of snapshot, and what will be the next immediate activity that should be done, or immediate research or follow-up research if we want to go towards surveillance. Tadi I'm also happy that you, for example, you asked for how the opponent handling the sample, and after they give answer, you challenge them back, and you answer, and then you challenge them back. I don't see that this is the way you want to prove that they are missing something, but you, from positive side, you really want to make sure that all necessary alternative have been considered by your opponent. So happy to know that. The last one, I do have something to say. Terakhir, apa ya? You suggest certain approaches, yeah, and you ask whether or not it will give you better result. And I'm happy that your group responds it kalem aja gitu, cool aja, say that that is a good point of view. So that's a good attitude ya during the debate. I mean, you don't be too defensive on what you are doing and ignore relevant input coming from your opponent. So that's very good. Thank you.
Okay, thank you. Once again, give applause for Team 41 and Team 51. You can get your seat back. Thank you. Very tight debate. Okay, for team, the next match for Team 54 versus Team 44. Get your seat, please. Fighting, fighting, fighting. Team 44 here and Team 54 here. Oh. Where's Team 54? Okay, get your seat, please. Please prepare for the PPT for operator. So who will go first?
Yeah, I think. Yeah.
Okay.
For
For Team 54, please prepare for the PPT first.
44.
44.
44.
Okay, and please prepare for the 3-minute slide.
Yeah.
Okay, you can start from now.
Yeah. Good morning, judges and everyone. Good afternoon. We are from D44. I'd like to present our research about AFB smear grade as a predictor of TNGS sequencing MTB detection, logistic regression, and trend analysis. Slide. Second slide, please. Yeah. For introduction, Indonesia, as we know, we are having a break of tuberculosis endemic, which is the drug-resistant TB and also the sensitive one, increasing time to time. And we also know that we already have a conventional methods to detect bacteria TB, but it is a long detection time and also low transmission is very dangerous. So we need urgent to rapid diagnosis to interrupt the transmission. So we have a rapid molecular testing like a gene expert. In 40 minutes, the first result can come up, and when bacteria can be needed, then we know the rifampicin resistant. And also we have acid fat bacilli, as we know the long time ago examination. Then we can very need the precision medicine need for TNGS. Although it is the very high resolution and high cost, but we are very need to know problem where's the study go. We can the AFB testing predict the TNGS success. The first one slide, please. Previous. Yeah. The methods of this study, we are doing the cross-sectional study with the sputum sample 579 sputum with AFB smear classified into the 3 positive, 2 positive, and the 1 positive, scanty also the negative. We doing the TNGS performed on the Illumina MySec, and DNA was extracted from the sputum using the KMLM DNA mini kit and assessed in is detected or not detected. And we know the relationship between AFB smear grade negative and also 1 positive and 3 positive, and sequencing success was assessed by binary logistic regression. Slide. And the result is the higher AFB smear grade is associated with higher odds of TNGS MTB detection. So as we know, it's in the polypop lollipop success rate diagram. We know that the best result is the 3 positive for the TNGF result. Thank you.
Okay, thank you for the presentation from team 54. And sorry, 44. Yes. Oh, you're 44 here?
Yeah.
44. Oh, okay, okay. Boleh. Daripada tawaran nilai ya. Iya, iya, iya. Okay, thank you for team 44. So please set timer for 6 minutes. Yeah, berapa banyak 44. 44 and 54. Okay. Okay, 6 minutes session. You can start now.
Okay, thank you for the presentation. For the first thing I want to ask is about you state in the title that the AFB smear grade as the predictor of the NGS, right? But on the result, you only stated that strong association by smear and likelihood of the NGS. Could you explain more how could this be, how the grading actually be implemented in the real?
It's because the TNGS is very costly and needs many resources, and so it's very pity if we do the TNGS, but the result it will be not detected MTB. So we need some predictor that can predict the success of the TNGS. So finally, we use AFB smear. Why? Because AFB smear is consists about 5,000 bacilli in 1 milliliter of sputum. That's a lot of bacilli. So we predict that the TNGS result will be detected.
Okay, but from but how about the negative result of the FB smear itself? I believe that it could also be tested with the NGS. And how do you maybe you could actually elaborate more on which grading could be used
to screen the TNGS?
Yeah. Our aim study is want to evaluate is it FB smear can be as a predictor for TNGS success. So all the AFB smear we concluded in this we included in this research. As you can see that the negative result of AFB smear still can TNGS detected, but already just only 55% about that. So this can capture the we conclude this as a this is the high tech of the NGS, so they can capture even the AFB smear still negative.
Okay, so I kind of see that's actually the problem because like if you we will probably test AFB first to screen, right? But how if the screening platform not actually as good as the NGS like or the actual one because how do you what do you think of how about these negative results of AFB to be detected to be further analyzed after if they're not assessed with the TNGS?
Okay. Maybe I want to elaborate more. So in your results, yeah.
Yeah, I think first for the screening we doing the gene expert first. Yeah. After that, after the gene expert positive, we differentiate by the FB positive 3, positive 2, and so on, and negative. The negative still can read by the TNGS, but only 55% positivity. But the positive 3, it can remain until 99% positive by TNGS. Yeah, that's.
Maybe I want to ask about how is the real world implementation? Is there we use the AFB now or we use the TNG now? Because from what me and my team understanding is the TNG is the for the diagnostic that used to detect the cases.
Yeah, actually, is it the BGSI TAP TB? We collect more than 5,000 sample from all over the country in Indonesia, and we check them all. And for the surveillance first and the precision medicine, as we know, as I'm a clinician, as a pulmonologist, you know that with the NGS we can see the hidden resistance. So my patient maybe not cannot be with BEPAL only. He already have another resistance in her body. So with now I can tell the MOH Kementerian Kesehatan to change the regimen.
So as you can see that it is very very costly, of course, but why we do the TNGS, because it can capture and it can detect the 13 mutation of the drug resistant.
But you highlight the importance of the TNGs, but what is the value of using AFP? Yeah.
Yes, the value is because we want to have some predictor before we conduct the TNGS examination. We must make sure first how percent will be success for TNGS. So we need some predictor. If we only do the gene expert, we cannot know because there are only capture the DNA. Just only one a few base cell will be positive. Yeah. So it's not very confident for us to predict the success of the NGS with gene expert.
Okay, time's up for the first round. So let me look your score now. 19 for team 44 and 13 for team 54. Okay, now we're gonna start the second round. Yes.
Good.
You can start from Now, okay, good evening, judges and everyone. My name is Cindy, and I'm here with my partner, Kalila. We want to present to you about our study that is comparison of TB1 and TB2 response in KFT Plus among TB contacts in Jakarta. Next, please. So we know that there are people who are having the Mycobacterium tuberculosis in their body but doesn't develop the disease yet called the latent TB. And it's very important for the high burden country to detect this kind of people because it can lead or progress to active TB cases. So one of the recommendation is to highlight the prevention with the diagnostic tools that is in our study is KFT plus. And for the KFT plus, there is addition tube that is TB2. So it can predict the CD4 and CD8 T cell response. So interestingly, you can just get the positive results of IGRA by just one tube. So either TB1 or TB2 is enough to get the positive results. So we wonder if there is any differences between the TB1 and TB2, and we want to compare both tubes by seeing by their positivity rates, correlations, and then factors associated with the interferon gamma.
Okay, next please. Next please. So in the study, we enrolled 299 participants who are met the inclusion criteria, which have minimum exposure of TB active patient prior to the study for minimum in 3 months, and then they are screened for LTBI using the IGRA QFT plus, and then for the interpretation of the IGRA itself, we use the manufacturer cutoff positive cutoffs, which is 0.35 for each antigen tubes, and then for the statistical analysis, we use positivity rates using McNamara's and then correlation and associated factor with univariate and multivariate linear regression. Next. So the first result is we found that the positivity rates for TB1 is 43.1 and then 46.5 for the TB2. And the McNamara test found that there's non-significant difference between both tubes. And then we try to assess the agreement between two antigen tubes, which using kappa coefficient, and there's a slightly perfect agreement. Next, please. So for the correlation, we use the log transform of interferon gamma value to detect the correlation in each tube. And then we observe there's a strong positive correlation with coefficient of 0.9453. Next.
For the factors associated, when we did the univariate, there's no factors, significant factors. Then next, please. And then for the multivariate linear regressions, we find that TB1 is associated with BMI, with the increase in BMI associated with lower interferon response. And then for the TB2 is associated with age, with older age significantly associated with higher interferon gamma response. And then for the conclusion, next please. We found that there is no significant difference.
Okay, thank you for the presentation from team 54. So set a timer for 6 minutes. Okay, and you can start now.
Yeah, thank you for the presentation. I want to ask about the you said that TB1 is stand for response for CD4 and the TB2 is for CD8 response, right? So how can this research can influence the screening strategy in Indonesia for the close contact TB?
Okay, thank you for the question. Maybe I want to clarify. The TB2 tubes not only detecting CD8 but also CD4. So that's why we really want to know the difference between both tubes because, especially for the TB2 tubes, like, is there any significant difference between TB1 and TB2? And for the implementation for screening in Indonesia, we know that, and the manufacturers also stated that the CD8 T cell response actually correlated with detecting recent TB infection, and instead for the CD4 actually that correlated with maybe like a longer infection for the TB. So maybe what we can suggest for from the data that we obtain, maybe we could get to look at the TB2 data and then to assess whether which.
Well, thank you for the explanation. But as long as we know that quantiferon is detect the immune system, our immune system. So I believe that you did this to the healthy people, not the patient of TB. Is that right? Okay. And then how the implication of the in the setting of the burden disease TB for TB because we are endemics. So and we already vaccinated BCG in the at child. So we have the immune already. So
Okay. So actually, the antigen used in KFT tubes is SAT6 and CFP10. From our understanding, that type of antigen actually eliminates the bias of BCG.
okay, thank you. And another point of view, how you make sure the confounder of the immune system in the healthy person, because sometimes diabetic mellitus is also as a comorbid as.
Okay. Thank you for the question. Actually, because we derive this data from a main bigger research, so this is the like secondary data. So that's one of our limitation actually, because we don't really know like the background of the each patient comorbidities. So that's what actually we need to improve more.
Okay, thank you. And I still don't understand why your research is matter, because if we found the latent TB infection, it doesn't mean it's active, right? Because the MTB is a dormant bacil inside of our lung. The implication of the clinical implication of the patient or the healthy person, what is the better to highlight this?
Maybe to answer your question, for the IGRA itself is already collect blood samples, minimal blood samples. So we want to know the efficacy of each tube. So if you found there is differences between the TB1 and TB2, we try to suggest that maybe we can use one of those tubes. So the patients will go to the public health facilities and their blood taken is not very much compared to the both tubes. So that is the implications of the health patients. But for the public health or maybe the government, it can reduce the cost of the IGRA itself if we use the one tube only. That is our concern when we do this research. So we want to know if there is differences between those tubes. Are they similar or are they different? Or they have the diagnostic value, different diagnostic value? That is why we did this research actually.
Yeah. I want to ask about in case with this concordant between TB1 and TB2 result, how should the clinician interpretation them, especially regarding the recent infection or infection in progression?
Maybe we could suggest to look at the quantitative data on TB2, especially because they could be maybe they could be the more prioritized to get the TPT because the correlation of like the CD4 and then the recent infection. Yeah, that's all. Maybe that's our implication.
So is that can differentiate recent infection or progression infection, yeah? Okay. And how can you research can change the WHO guideline then?
For this research, actually, our sample size is very small, so we could only contribute to the future research for whether to use one tube or both tubes. So for changing the guideline of WHO, I think it's than our intentions. Yeah.
Okay, that's all. Okay, give applause buat Before and
Kenapa? Kenapa kalah?
Congratulations for team 44. Just stay here first. Just one comment from Ibu Putri. Yes. Sorry.
Capek ya Bu. Finally, apa nama? Yeah. So I would like to highlight first what went well gitu ya from the both groups. First, you both clearly articulate in the presentations and also the question. Yeah, the questions and also the answers sessions gitu ya. Jadi that's really make the debate really apa hidup gitu ya. And also maybe because you both are on TB gitu ya. Jadi the oh iya. Oke. Ya, jadi no wonder that the questions are on points gitu ya because specific ya, really specific so, apa namanya on that field gitu ya. Jadi ya as a audience I just penonton ya sama popcorn gitu ya. Ya udah enjoy gitu the discussion. Yeah. But that's what went well for both groups gitu ya. Maybe that the one that can be improved if you both go to the next round. Again and again, no follow-up questions after you address a clarifying questions gitu. Jadi, for examples, grup di 44 apa namanya? Tadi ada tadi saya nggak nyatet tapi ada satu no follow up. You ask about something, you need to clarify, but then okay that's it gitu. And for di 54 sudah lelah jadi maaf. You ask about limitation or using secondary data, and also apa namanya so you cannot measure the confounding or comorbid etc. But then okay. Maybe you can ask something like, how can we trust your research? Maybe something just an easy as that gitu. Okay, that's the limitation, that's the cons. So how can we trust your research? I also appreciate that your group mentioned about the limitation apa namanya using TNGS beside of the cost, but also you elaborate more about okay, this is we have limitation on the cost, and then but then TNGS can detect 34 34 sorry. Yeah, that one. Mutations gitu. And then again openly mention about the limitation on TNGS. So that's I think is a good like Bu Adis mentioned before, it's a good intention of the research because no research are perfect. Yeah, there's always room for improvement. So yeah, that's what I enjoy.
Okay. Thank you. Give applause again. Congratulations for team 44 and thank you for team 54. All right. We arrived at the last match for today tournament. So I will invite for team 60 versus team 36. Are you here? Come on. Please sit down here for team 60 and sit down here for team 36. Okay, the last match. Come on. Fighting. Okay, who will be the first? Yeah, switch or by agreement? Up to you. Okay, you will be the first or you will give the chance for them? Go first. Okay, please prepare for slide team 60. For team 60, just wait a minute. Fighting the last match, okay? Okay, fighting. Okay, you can. Are you ready? You can start. Okay, you want to our operator help you? You just mentioned next. Okay, this one? Okay, so for team 60, you can start now.
So before running our presentation, let me ask you one simple question. If you know that smoking causes various health problems, what about the health risks of tobacco farmers? Therefore, I'm Gergis and my team member Aiman will going to present our current work entitled PPE Compliance, Green Tobacco Sickness Toxicity Patterns, and Cardiometabolic Profile Among Tobacco Workers in Temanggung, Central Java, a cross-sectional study. Next. So, green tobacco sickness or GTS is caused by transdermal nicotine absorption from wet tobacco leaves, and the symptoms, by the definition, is the nausea, vomiting, headache, abdominal cramps, and also excessive sweating. And among the globally, GTS affects approximately 1 out of 4 tobacco workers, and especially in women bearing a higher burden. And as we know, the personal protective equipment is preventing from the nicotine exposure. However, in Indonesia cases, more than 87% of Indonesian tobacco farmers use PPE inappropriately. Therefore, it can doubling their GTS risk. So our aim of this study is to assess the association between the PPE compliance level with the clinical GTS toxicity patterns and also the cardiometabolic profiles among tobacco farmers in Temanggung. Next. So for the methods, we are using the cross-sectional study where we conducted among active tobacco farmers in Temanggung Regency with the inclusion and exclusion criteria. Next. So for the result, as we can see here, the first one is about the GTS risk factors. As we can see in here, the first one is the employment duration is the strongest predictor where workers with a longer duration of work with the tobacco field, which is more than 10 years experience, so the highest GTS association. And then another one is longer daily exposure amplifies risk, where each additional hour of field work increases the GTS prevalence. And the male workers carry a disproportionate burden, where males saw a GTS incidence about 52.9%. Next. And the second one is the association between the PPE compliance level with the clinical GTS toxicity patterns. And from the MCA or multiple correspondence analysis, we can figure out that the inconsistent use of PPE use correlates with the intermittent GTS symptoms, where the frequent PPE user, especially in women and non-smokers, saw the lower symptoms frequency. Next. And the third one is the association between the PPE and the cardiometabolic profile. And from this principal component analysis, we can figure out that the workers in the upper right area combine higher metabolic risk markers with lower of knowledge, attitude, and practice, making them as the priority group for behavioral and clinical intervention.
Okay, thank you for team 60. Okay, set a timer for 6 minutes first. Okay, ready? Okay, you can start now.
Okay, thank you for the great presentation. My first question about why you choose the cross-sectional study rather than the cohort study, because your result is reflects to the GTS toxicity. I think it's better to use the cohort simulation for the longitudinal time to see the GTS toxicity for the GTS farmer. Thank you.
Okay, thank you for great questions. Why we use the cross-section analysis? Because it's our objective to estimate the prevalence and the risk factor first, and we will not we are not willing to search for the causality factors at the first. So our first is a pilot study to further cohort studies, because in Indonesia it's still currently limited about the GTS prevalence, especially among tobacco farmers.
Okay, I mentioned and at your background that the cause of the PPA is transdermal absorption in wet nicotine, just like that. But in your result, there's also, I don't know, a result or the data. It's include the smoking criteria, which is we know that it's absorbed with the inhalation. So why can it be biased on your result?
Okay, thank you for the questions. Regarding the confounding bias, we have another analyze it to adjust that preference rate, and we show that PPE has a significant role association with GTS. So a proper PPE is associated to less GTS symptoms, and especially for the smoking, we found that there is negative results as well as
the previous literature mentioned about the nicotine paradox. So our results found that non-smokers is tend to more vulnerable to GTS rather than smokers because the nicotine resistance in the smokers population.
Why you not simplify in the beginning, because it can give you a lot of data that can confuse in the conclusion if if you still use the smoker data.
Okay, due to the time limitation, we use the data to do further discussion, I think.
Yeah, so a little bit. I want to add just from my college answer. So basically, we are performing the cross-sectional study, and this cross-sectional study is only one-time visit. Why we perform this study? Because because of there is a limit data of the PPE. Yeah, and also in Indonesia there is quite a lot time, a long time ago to perform this study. So that's why we want to seeking this current condition, and why we also include the tobacco the smokers, because of as we know the habits of the tobacco, maybe because of they also produce the tobacco, so some of them also perform the smoking, even active or passively, even men or women. So that's why we also include this variable in the into our characteristic of.
Okay. Beside you include the smoking criteria for your research because it can make a bias. Why you not make a more a longer area or longer setting that can you save your sample like that?
Yeah. Okay. So why in this study, as we mentioned before, this is the pilot study. So in this pilot study, we are seeking the association first between the PPA and the toxicity patterns and also the cardiometabolic, and the region that have the highest population of the tobacco workers are we selected the location for our research based on the which region or area that have the highest population of tobacco workers, and we figure out that there is Central Java, especially in Temanggung, which is there is so many village, and most of them are farmer. Even the tobacco farmer itself, or even the other farmers that also have the tobacco in their field.
Okay, thank you for the next question. That you mentioned for the GTS symptom is about nausea, vomiting, and anything else. That how you to differ for the symptom effect from the GTS with the other illness like that, because it's like a general symptom for GTS. Yeah, other.
Okay, in our study we include a medical doctor to confirm about the clinical appearance regarding the symptoms and signs and symptoms about the patient. So it was confirmed by the medical doctor.
Yeah, so and despite of the including the medical doctors into the collected data, we also perform the questionnaire self assessment to the participant whether they can assess by their own self, because we do not only ask whether they have this criteria or not, but we also assess whether how many times after work. So the questionnaire, the self assessment questionnaire, is based on the question that we asking about the patterns, and also the time how long after they work with tobacco.
Okay, thumbs up. Okay, give applause for both of you. So you can put the score there. For team 60, the score is 10, and 13 for team 36. Okay, go to the next round. Are you ready? Okay, you can start from now.
Okay, good evening, everybody. Today we want to present our research titled Cost Effectiveness of Multi-Target Stool DNA-Based Screening for High-Risk Colorectal Cancer Population in Indonesia, a Markov Model Study. So, do you guys ever think that the screening is really meta? Next.
Yes, for CRC, screening declined about 50% mortality of the patient. But in contrast, next, the compliance rate decreased over decades. It's why the lower of the FIT as the modality of screening is decreased, which is mean the increases of colonoscopy demand. Next. So is there any alternative? Yes, there is a stool DNA test that have a similarity with FIT with not invasive then offer the higher sensitivity, but it's more expensive. So it is applicable for Indonesia. So we want to address this issue next. To compare the cost effectiveness of FIT, Colotek, and no screening among high-risk CRC population in Indonesia. Next. We do Markov simulation model to analyze the disease progression about 100,000 population with the intervention with Colotek and the comparator to FIT as the modality and then without screening. We observe the ISR of each parameters. We also do scenario analysis to evaluate our strategies under different screening intervals and the coverage level. To uncertainty analysis, we do one-way sensitivity analysis and probabilistic sensitivity analysis. Next.
Okay, for the result in the base case analysis, that the ISO value yield in 91.2 USD per quality that remain or deem cost effective because it's under willingness to pay in Indonesia. And then for the also for the scenario analysis is deemed cost effective because all the ISO value in scenario analysis is under the willingness to pay in Indonesia threshold in Indonesia, and the best scenario is scenario 5. Next. And this is for the one-way sensitivity analysis. Both of them, the parameter that make ISR has wide range is the discount rate of utility and discount rate of cost, and also the cost of Colotek. Next. And this is for the probabilistic sensitivity analysis in the left side that at the willingness to pay in Indonesia, Colotek demonstrated a 100% probability of being cost effective. And when the Colotek compare with how screening or population do no screening, at the willingness to pay threshold, the Colotek demonstrated at 99.9% probability of being cost effective. And next. And this is for the conclusion of our result that Colotek demonstrate a potential as cost-effective colorectal cancer screening strategy for the high-risk population in Indonesia with a scenario 5-year screening interval with a 63% coverage yielding the most favorable answer outcome. Next. Okay, thank you.
Okay, thanks all. Thank you for the presentation from team 36, sorry. So we're gonna set a timer for 6 minutes for the debate. Okay, are you ready?
Yes.
You can start now.
Okay, so our first question is, how was the willingness to pay threshold determined? It is coming from the GDP per capita multiple, and why is the 63 coverage considered optimal instead of 100%?
Okay, thank you for the first question. How we calculate the WTP threshold in Indonesia based as said you before, right? From the GDP or those GDP gross domestic product in Indonesia, that the data is shared from the statistic for the statistic data in Indonesia that from the Kemenkes or for the Kementerian Kesehatan Indonesia mentioned for the willingness to pay in Indonesia is 3 times for GDP. 3 times GDP. So we calculate the 3 times GDP to make or to calculate the willingness to pay threshold in Indonesia. And the second question?
And for second question, why how a 100,000 population can demonstrate right? No.
Because in the previous study in Indonesia that already for the already detecting already.
Okay, so yeah, if you mention about the GDP per capita, say don't then you need to like make sure like the convert between the Indonesian rupiahs and also the US dollar to let the audience know how you calculate the GDP per capita. And our next question is, ISR is extremely low. Is this realistic? Because you mentioned that in your result, the ISR is about US dollar 9.12 per kali. And could you...
Okay, thank you. Yeah, our result for ISR is like cost effective or has the low value, and then we move we continue for the sensitivity analysis for see the robustness for our model to make decision for the ISR value that we can see for our result in the sensitivity analysis. For the one-way sensitivity analysis, that's when we change the parameter for minimum or maximum value, there's no different change for the ISR value. But we can see there's a wide change for the ISR, but the ISR value is remain under willingness to pay in Indonesia. So for our model for make the conclusion of the ISR is robust like that, and with PSL2 probability sensitivity analysis 2 is being cost effective in 100% probability.
How sensitive is ISR to collect price changes?
As my friend mentioned before, we conduct a sensitivity, one-way sensitivity study that we do minimum and we input the minimum and maximum value of the Colotech. Each parameter include the cost of Colotech itself. So if the Colotech, the cost of Colotech change, it will it still give the lowest ISR with compared to the WTP.
Yeah. Because we change the ISR value, the cost with the minimum and maximum value, and the wide range of the ISR is still under WTP threshold like that.
Okay, so our next question is, how generalized is this model to average risk population? Would your result differ in like rural versus urban area in Indonesia?
For the high population, we do screening for the age 45 until 85, which is it's the definition of the Permenkes for the high population of CRC. And for the rural and the urban area, it will be our consider to the next study because the data itself is still limited. So we do this by the age.
Also, there is no chain. There is like my friend said before. There's no the data for the rural and the urban area for willing to doing this screening like that. So we hope that our result can be being the policy brave to include this result to the BPJS. So all the population in Indonesia can get this screening like that.
Okay. But you also need to make sure because the data that you work with is only an assumed data. It is not like the surveillance data or the data that you really collect in Indonesia. Yeah, those are coming from other countries. And regarding to your ISR, where it is only US 9.12 per kali, which parameter contributes most uncertainty, and how robust is the model if Colotech price increases substantially?
Okay, thank you. That's I said or I mentioned before in the sensitivity analysis that the parameter have to change specific for the ISR value is three: discount rate of utility, discount rate of cost, and the cost of the Colotech. When we input the cost of Colotech with minimum pricing from right now is which is 25% under the price right now. With the maximum is plus 25% under price right now. So when we can see the ISR has the wide range, but also but remains still under the willingness to pay threshold in Indonesia. So it's make our model is robust to do like that.
Okay, so the winner of this match is Team 36. Congratulations with the score 25. Okay, thanks to Team 60. So you can get the picture.
Udah siap-siap. Yeah, it's okay. Then. Yeah. Great job, both of the teams. It's really exciting to see you both. Maybe just a bit of feedback. I know you both are already fighting since in the morning. So for team 60, they asked a great question about how you address bias, and some of them is about questionnaire. Like you said, you answer. I think you answered greatly also about you validate with the questionnaire. You ask the people right about the questionnaire, but please address the recall or attention bias. I don't think you didn't mention about how you address recall bias, right? Especially in questionnaire, it's a very big problem for a questionnaire. And also about why you include smoking. People who are smoke also includes in your population, and you should address it clearly because if you can answer it more meyakinkan gitu, yeah, we judges will. I think we will give you great points, but I think your answer didn't like make us apa yakin gitu loh. Jadi maybe it would be your strongest point if you can address those. And for the team 36, they asked a great question. How about the willingness to pay? And you said about Kemenkes, how you validate 3 times apa GDP ya itu. So I think like please elaborate more how you can get those number 3 point. And then also assuming because your data is from assumption, I think it's how do you address those also because your data is assumption and you said that you want to make it believable for BPJS. Meanwhile, BPJS has a lot of data that you can access. My question maybe you can follow up like why don't you use BPJS data then? Why you use assumption data? I think it would be I would give like strike 2 points if you can ask those critical question. Yeah. So thank you for the great competition here. Congratulations.
Okay, once again, that's complete our tournament today. Give applause for Team 60 and Team 36. Okay, you can go back. Okay, thank you for judges too. Thank you for this all of Sensei. So that's wrap our Shinjitsu tournament today. Get your rest and then come back stronger tomorrow. Okay. So just for information, we can get back for tomorrow Shinjitsu tournament. We can begin at 8 a.m. Okay, so we can start shortly for tomorrow's session. So for all participants, judges, and all sensei, thank you so much and see you tomorrow. Bye.